Morning, ladies and gentlemen. Welcome back to our final day of this IAC 2023 here in the beautiful city of Baku. It has been a tradition to open the last day of the IAC with a session dedicated to late-breaking news. And what would be more fitting than the outstanding, exciting mission and success of Chandrayaan 3. And therefore, I welcome you to this session, Chandrayaan 3 Lunar South Pole Landing Endeavour, the initial results in exploring lunar South Pole. It is of great gratitude we have towards ISRO that they chose the IAC 2023 as the exclusive venue to unveil the preliminary results of this historic mission to the lunar South Pole. And it is now my great pleasure to call on stage Dr. Anurup, Dr. Gaurisankar, Dr. Kumar, and Dr. Joseph. Please give them a round of applause. While the gentlemen are taking seat, I would like to remind you that this is certainly a session where you will have a lot of questions to our speakers, and they are very happy to answer them. So please use our Slido system. You saw the slide up here, how to do that. Use our app, use Slido, and be active, ask questions. They will be happy to interact with you. Thank you. Gentlemen, the floor is yours.
Very good morning to all, and thanks Dr. Christian for the nice introduction, and thanks for giving us this opportunity to deliver the talk on Chandrayaan 3 as the late breaking news to the IAC community. So this is how we have structured our presentation. What I am going to do here is, I will be giving a brief introduction on our lunar exploration program, the evolution leading to Chandrayaan 3. And Mr. Anurup here will be talking about the Chandrayaan 3 configuration, how it got evolved, and something about the tests and the simulations done. Dr. Anil Kumar will be talking about the mission itself up to the lunar landing. And finally, Dr. Gaurisankar will give the insights into the scientific instruments and some of the results from the experiments. So, to start with, this is how we evolved our lunar exploration program. We had Chandrayaan 1 back in 2008. It was basically an orbiter mission. There was no lander in it. Chandrayaan 2 was done in 2019. It was a full-fledged mission with the orbiter, the lander, and the rover. And the orbiter is still functioning very well in the lunar orbit, but the landing part, as we all know, did not succeed. And now we have Chandrayaan 3 this year, 2023. So, coming back to Chandrayaan 1, this was our first mission. And as we can see here, the Chandrayaan 1, the satellite mass was around 1,400 kg. Because at that time, we didn't have a bigger launcher. So we had to use our PSLV, the Polar Satellite Launch Vehicle, to launch the Chandrayaan 1. So the satellite mass, we had to limit it to around 1.4 ton. But then we had a suite of scientific payloads from India as well as from multiple countries, from US, from European countries. And the outcome is we have more than 180 scientific publications. And of course, the detection of water molecule on the moon by the M3 payload by NASA was one of the greatest achievements at that time. So we launched Chandrayaan 2 in 2019, and that was our first landing attempt. Now we can see the mass is around 3,900 kg, almost 4 ton, because at that time we had a more powerful launcher, the LVM3. So we were able to carry much bigger payload. And we are going to hear more about the launcher in the next presentation. So Chandrayaan 2 was a full-fledged mission. We had the orbiter, we had the lander, and the rover. And the orbiter is still functioning very well, giving many scientific results. And what is shown here is some of the images taken by the terrain mapping camera on board the orbiter. Again, some of the images taken by the Chandrayaan 2 orbiter on the moon. So on the left side here, what we are seeing here is a SAR image taken by the orbiter, and alongside it, we have the optical image also. So what we are trying to bring out here is the subsurface features on the moon's surface are captured very well by the SAR image. And the right side, what we see is the high-resolution image taken by the OHRC, that is the optical high-resolution camera. That is what is shown on the right side. And a zoomed view also is shown on the far right. So what is important here is we have used these images of this OHRC for Chandrayaan 3 landing also, for finally defining the landing site. And another important point is the orbiter served as a communication link between the Chandrayaan, during the Chandrayaan 3, between the communication link between the Chandrayaan 3 lander and the Earth. So it acted as a redundant link in addition to the direct main link from the lander to the Earth. So, as we all know, the landing attempt during the Chandrayaan 2, we could not succeed. So what is shown here is the landing profile. We have in the vertical axis, we have the altitude, and on the horizontal axis, we have the distance, that is the downrange. And also the time also is plotted here. And what we can see here is the initial phase, the phase 1, as well as the phase 2, that is the rough braking phase. In both phases, up to altitude of around 7.4 kilometer and the range of 8.3 kilometer, the performance was okay and it performed well. But during the third phase, which is called the camera coasting phase, there was larger thrust dispersion, larger thrust in the lower throttling range because of certain logic issues in the thrust control algorithm. So what happened is in the final phase, that is the fine braking phase, It resulted in higher velocities and loss of altitude, which the software algorithm couldn't handle the dispersions. So it resulted in crash landing. So what we have done in Chandrayaan 3 is we have tried to introduce better thrust control system, and it was implemented. And we made some changes in Chandrayaan 3, both in the software algorithms and as well as robustness in hardware, so as to improve the overall ruggedness or the robustness to handle the wider dispersions. So in a nutshell, what we are trying to tell is we try to maximally utilize the heritage from the previous missions, Chandrayaan 1 and 2. We built in more robustness, more number of ground tests and simulation, which are closer to the actual flight was done, and also better features were introduced, including features for on-orbit testing and corrections if required for arriving at the final configuration of Chandrayaan 3. So Chandrayaan 3 is our return to the moon, and the objectives was first to demonstrate the safe landing, followed by the rover deployment, the movement of the rover on the moon surface, and then conduct the in situ scientific experiments. So this slide gives in a nutshell of how we are going about it. The launch was on 14th July from Sriharikota, India, and then we had 5 earth burns around the Earth, followed by the injection to the lunar transfer trajectory. So we had the lunar orbit insertion on 5th of August, the lander separation from the propulsion module on 17th, and finally the landing on the moon on 23rd August. And it was supported by multiple countries, ground stations across the globe, from India as well as our partner countries. So thank you, and Andrew will be taking over from here.
A very good morning to all of you. My previous speaker, Mr. Victor Joseph, had covered how the Chandrayaan program of India evolved and how we implemented the lessons learned towards the success that we are seeing in Chandrayaan 3. So I'll be taking you through what were the mission elements on the Chandrayaan 3 up to the launch phase. So these are the various mission elements. Obviously, we have the launcher, which injected the Chandrayaan 3 to a highly elliptical orbit of 170 into 36,500 kilometers. And the Chandrayaan 3 mass was just slightly more than what the spacecraft mass on the Chandrayaan 2. The composite spacecraft consisted of the propulsion module, which was mainly the function of which was to take it from the Earth orbit to the lunar orbit, followed by the lander module and also including the rover module. As you can see from the slide, that the mission objectives were, of course, a safe and soft landing, and the rover and in situ scientific experiments. And there were 3 scientific experiments on the lander, 2 on the rover, and propulsion module on 1 number. In the successive slides, you will see that how Chandrayaan 2, which was launched earlier, played a very complementary role in ensuring the success of Chandrayaan 3. So what were the improvements in Chandrayaan 3? My previous speaker had introduced the root cause of the issues that were faced in Chandrayaan 2. So basically, we had to improve upon the propulsion, the propellant feed system, and also improve upon the guidance and control algorithm in order to provide a highly reliable, safe, and soft landings. In the process, we also improved the robustness of the lander legs and included full redundancy for the sensors so that we get, there are no points of single point failure, and the enhanced the simulations and ground tests so that we rigorously test and test until you are fully satisfied that we have actually tested as you fly. So these were the special tests and simulations. There are a lot of, it was really a painful process for us to actually devise new test beds, special tests, including all the conditions and distortions that can happen during the landing phase. So mainly we had 3 tests. The integrated cold test where only the sensor, all the integrated sensors were tested on a helicopter at various altitudes. Then the hot test with the actual thrusters firing, and several profiles of the lander leg drop test. So I'll be just showing you a video of the various tests. Just sit back and watch. So this is, yeah. No, we need to play the video.
ICT was conceived to validate integrated performance of all sensors, NGC hardware and software algorithms. An Mi-17 helicopter was used for ICT to test sensors for its entire operation regime, including hovering at 1.3 kilometers, 800 meters, and 150 meters, and lower altitude tests up to 10 meters altitude, which couldn't be done in LSPT during Chandrayaan 2 due to limitation of aircraft operating range. The tests were done at Chitradurga, wherein a special test site with simulated lunar craters were created to simulate landing site. 25 hours of flying time was used to conduct several tests with different combinations of sensors. The outcome of ICT provided several takeaways to fine-tune sensor parameters. The successful conduct of integrated cold test has provided greater confidence in the performance of all the onboard sensors and associated navigation algorithms. Integrated performance of all sensors and NGC was evaluated under engine firing condition for the first time in IHT. A set of dry run tests, static tests, closed loop tests, deboost and compact mission profile tests were conducted as part of IHT. Hovering and vertical descent of lander is demonstrated in IHT, and this has enabled successful validation of closed loop performance of all sensors, propulsion system, navigation, guidance, and control algorithms. Performance of optical cameras and 3D output of LHDAC is also validated in these tests. The test was conducted at SDSE Shah, which provided a benign weather condition in comparison to Chandrayaan 2 NABT test site. Simulated lunar craters were created for IHT-2 for LHDAC performance evaluation. The successful conduct of IHT has provided great confidence in the overall system. Improved design of lander legs was validated through a series of drop tests starting from component level to integrated simulator and QM structure level, with different touchdown conditions such as on hard surface, soft surface, flat bed, 12-degree slope bed, simulating different combinations of vertical velocity and horizontal velocity. A new facility was realized at QRSC to have a 11 meter by 7 meter test bed with flat and inclined drop surface. Lunar simulated soils were used as contact media for drop tests.
Yeah, so as you can see, the amount of tests that went into the mission is just enormous, and multiple levels of reviews are held to actually go through the outcome of these results, and all the whole process and configuration was further refined, and finally we have the results to show. So now I just go through the individual mission elements. Of course, the lander, which we named as Vikram after the founder of ISRO, Vikram Sarabhai. Yes, the lander was had some instruments, the communication with the deep space networks. Then there was also a communication with the earlier launched Chandrayaan 2 orbiter. Then next we had the Pragyan, the rover, with a mass of 26 kg with 2 payloads, and the main communication was with the lander, from where the lander would further communicate to Earth. And finally we come to the launcher. So as you know, the LVM-3 is a newly operational launch vehicle, and the first operational flight was used for the previous Chandrayaan mission. Subsequently, there were 2 other commercial missions for OneWeb, and the 4th mission was earmarked for this prestigious Chandrayaan 3 mission. And having the heritage of these missions, and the launcher did do its job fantastically to inject the satellite to the precise orbit from which it could be taken towards the moon, towards safe and soft landing. Further, I would call upon Dr. Anil Kumar to take you through the post-launch operations and the further mission operations until we achieve the landing. Thank you.
A very good morning to all. And as you know, our Chandrayaan 3 landing, it's one of the greatest achievements India has in the recent past. And it has attracted a record number of viewers in the YouTube as well. And in fact, YouTube authorities have congratulated ISRO for that purpose, and about 4 billion live at that time. So much enthusiasm was there in the Chandrayaan 3 landing event across the globe. And now I will directly go to mission aspects. Now, considering the mission, especially there are 3 important phases in the mission. One is Earth-centric phase, second is lunar transfer phase, and the third is the moon-centric, lunar-centric phase. In Earth-centric phase, first one is pre-launch phase. Pre-launch phase, as all of us know, that satellite is mated with the launch vehicle, and all types of simulations are carried out, checkouts are carried out, interfacing the ground segments together with the satellite. All network simulations are done. A full rehearsal as on launch day, it is carried out 2 days, and made sure that everything goes well. And also, for lift-off clearance of the LBM-3 vehicle, so that it can be, inject the satellite into a proper orbit safely. Collision avoidance analysis are carried out, and based on the collision avoidance analysis, the lift-off time was shifted by 4 seconds, so that there was no collision threats for the orbiter for the Chandrayaan 3 in its injected orbit. And also, all ground software, they were tested well before the launch as part of the pre-launch simulations. And launch and ascent phase, as we know that liftoff is taken place very smoothly, and it was a textbook launch. And during the ascent phase, all the parameters were monitored, telemetered to the various ground stations owned by India as well as other foreign agencies. And all analysis, all health parameters were online checked, and all the systems were perfectly working. All the stages were nominally working, and it injected into a precise orbit of the Chandrayaan 3. And we do carry out preliminary orbit determination based on the NAINS data, navigation data available, GPS data available from the onboard, and it is showed that it is a perfect launch with very less dispersion in the achieved orbit. Then After it is going into orbit, the important activity is attitude control, acquisition of attitude and the orbit. And orbit determination is a process. And orbit determination is carried out from using the ground station data, telemeter data, and a precise orbit was found out before going for earthbound maneuvers. Then it goes for earthbound maneuvers plan. As we can see that there were 5 earthbound maneuvers altogether, and which gives each maneuver will make, first it was in a GT orbit, then each maneuver will make a perigee thrusting using our thrusters in the spacecraft, and it will make the apogee larger and larger, imparting more delta V velocity to the spacecraft. At last, it has to go to a transfer lunar orbit. Okay? So for that, earthbound maneuvers, 5 earthbound maneuvers were there. All the 5 earthbound maneuvers were done properly, and after each earthbound maneuvers, there were a critical look into the aspects of the mission. All the health parameters were checked, all the telemeter data parameters were checked, and all the orbits were reanalyzed and calibrated. The calibration is done during calibration of the many systems, including navigation systems and thruster capabilities. Everything is done during the earthbound phase maneuvers, and some cameras were, payloads were operated, images were taken as a calibration process. Then it goes to transfer lunar trajectory, and basically it goes from earthbound orbit to the Moon's orbit of 3.885 lakhs kilometers, and this was TLI was done perfectly, and with enough velocity was imparted to this spacecraft so that it goes to a transfer lunar orbit. Then it goes for the moon-centric phase. In moon-centric phase, first important thing is lunar orbit insertion. So the delta V added to the spacecraft, which was taken to apogee of 3.85 lakhs, that has to be reduced to about 1.6 km per second, so that it is captured by lunar orbit. It goes for a highly eccentric lunar orbit. It is captured there. Once it is captured there in the lunar orbit, it again goes for reducing the velocity, delta V reduction, so that it has to go for a final 150 km by 150 km circular orbit around the moon. So that is what done. So these are the moon-bound maneuvers. Again, you can see that there were 5 moon-bound maneuvers. And like I said earlier, after each of the maneuver, we were critically looking into all the data available. And if any corrections are required, that corrections being done, small corrections, mid-course corrections were done, so that it is actually goes for a geometry which is required for moon landing. Lander requires some particular geometry so that it will land in the designated place. Then it comes for, there is a propulsion module is there, and lander with a rover is there. It has to be separated from the propulsion module. Lander has to be separated. Then only lander will descend. So that again, that separation is one of the activity carried out in that phase 5. Then again deboost phase. Actually separation is happening by 150 km by 150 km lunar orbit. There again separation deboost happens. 2 deboost maneuvers are there, so that it will be taken into 150 km by 30 km perigee in the lunar orbit. Then it goes for a pre-landing phase. All the calibrations again done. All navigation parameters, bias, drips, everything has to be compensated, and we have to estimate the thrust levels, whatever we are getting from the propulsion systems. All those things are done, carried out. Based on that, the trajectory is finalized, fine-tuned, and also for the landing, we have a throttleable engine is there, so that according to a profile, pre-designed profile, the engine will be throttling, and accordingly thrust will be generated, so that we can go for a soft landing. Then once it lands, there is a normal phase of rover comes out from the lander, and also other activities like rover movement, etc. were there. Now, as far as Chandrayaan 3 is concerned, now propulsion module is in lunar orbit, and lander and rover in the on moon. Now you can see the details of the all earthbound maneuvers here, and first satellite was injected into a elliptical orbit of 170, GT orbit of 170 km by 36,491 km, Then each phase, day by day, you can see that dates are available. June 14th, we have Earth parking orbit, it is there. EPO, it is there. From Earth parking orbit to first maneuver goes for 42,000 kilometer. Apogee is getting, always perigee will be nearly 200 kilometer. Apogee is getting added up, and it first bound maneuver goes to 42,000 kilometer. Then again there was a apogee correction maneuver. Apogee maneuver was there. Apogee correction maneuver was there. About the perigee is increased to 225 kilometer. Then finally it goes for, after last earthbound maneuver, it goes for it goes from 1,20,000 kilometer apogee to 3,85 kilometer in the LTA, trans-lunar injection, TLI. It goes. Then when it comes to lunar orbit, see, it is captured in a lunar orbit of 18,000 kilometer apogee and perigee of about 166 kilometer. And with that, again we have gone for reducing the velocity so that it goes down to, after the fifth maneuver, lunar bound maneuver, it goes down to 153, about 150 kilometer circular orbit. Then we will go for the next two deboost maneuvers for preparing for landing. Their separation happens at 150 kilometer, lander and the propulsion module. Orbiter, in fact, or propulsion module is an orbiter. And then it goes for, separation happens at 124 by 160 kilometer, and it goes for first deboost. It reduced to 100 kilometer by 150 kilometer, and second deboost reduced the perigee to 30 kilometer. Then landing happened from 30 kilometer by 134 kilometer. The landing sequence is initiated. Now you see here, the lunar landing phase is a very important phase. There are four phases. First phase is rough braking phase. Second is attitude hold phase. We have to control the attitude. Third is fine braking phase, and last is the terminal descent phase. Okay, vertical descent is happening there. Now in the rough braking phase itself, most of the velocities are killed. Velocity whatever was there for the lander, it was killed in the rough braking phase itself. You can see that from 1.6 kilometer per second, 1.7 kilometer per second, it has come down to about 350 meter per second in the rough braking phase itself. Okay, and from there it took about 11 seconds, 12 minutes. It took about 12 minutes thrusting to do that. Then once it comes to and from 30 kilometer, it is coming down to about a 7.5 kilometer during the rough braking phase. From 7.5 kilometer at the end of the rough braking phase, the attitude hold is there. See, we have to control it. Control has to work in a closed loop thing. Now, control navigation guidance, NGC works in tandem with all the onboard systems. It works autonomously, and it's a closed loop system. And control is attitude is attitude hold was done in that phase. About 10 seconds attitude hold was there, and from there their velocity reduction is not there. From there it has to come to soft landing velocity requirement of 0 meter per second. So for that it again take about 3 minutes time deboosting, fine braking phase. There in fact here the actual algorithm works brilliantly, so that guidance, command and control and navigation. Navigation, we have a system LIRAP. It's a laser-based gyro, and this system and accelerometer system package. This system perfectly worked and provided the necessary inputs for the control and guidance. So under the fine brake, at the end of the fine braking phase, it has come down to about 0 meter per second velocity. It is still, and it has already reached about 800 meters altitude. So from there, a vertical descent happens. Actually, the onboard lander imager, it will be imaging the land, specified land where to land it, the location. In fact, last 3 years, our CS2O, Chandrayaan 2 orbiter, it's a high resolution camera, onboard high resolution camera. It was imaging the landing site, and it made a lot of analysis, image processing, signal processing, and power spectral density analysis, spectral analysis, and generated a DEM, that is digital elevation model, for the landing site. So the lander is having onboard loaded DEM value, and whenever the image is coming, the lander will be checking, onboard it autonomously checking whether it is perfectly matching with even pixel level it is matching or not. Then it is deciding to go for landing. If in case if there is an anomaly found, or boulders are found, obstacles are found in the land, actually there is a provision for retargeting the landing also. But here what happened in Chandrayaan 3, it went perfectly and prime landing site. Actually our dispersion was very small for that 500 meter by 500 meter, it has landed perfectly in that region. That is what happened. All the system parameters, all the navigation, all guidance, all control worked perfectly and we got to the perfect landing. Now come to the ground segment support. Already our Victor has told that we had a global support for the ground systems, and India has got many ground systems which is supporting like for the launch phase and initial earthbound phases, all the ground stations from Bangalore, Lucknow, Port Blair, Mauritius, Biak, Brunei, these are all owned by ISRO. And we have a deep space network with 18-meter antenna and 32-meter antenna. These are all supported all our until the moon phase. Now, we have support from SSC, that Hawaii and Santiago support was there real time, and we have support from ESA, Kuru, and Gunhili. Then, we had support from JPL, we had Madrid support, Canberra support, Goldstone support, but it was offline support, and we were using those data for orbit determination and analysis, everything. So, there is support from ESA, SSC, NASA, JPL, and our own deep space network we used for all this, including EBN and LBNs. Now you can see that rover path planning. Once rover is in the detached from, slided from the lander, it reaches the moon's land and it started rover path planning. And rover path planning is done ground based, and there is a LI camera, that is lander imaging camera is there in the lander, and a rover is having rover imaging RI camera is there. They are imaging the place and finding out whether any obstacles are there, any hurdles are there, and those images are sent back to ground, and we are analyzing that, and the necessary command is given to rover for rover movement. So rover path planning is an algorithm with its optimal path, avoiding all the obstacles, boulders. Actually, you can see the slope in which a rover can move is less than 20 degree. So if it is more than 20 degree, we are not avoiding that path. Similarly, hazard boulder size, more than 50 mm, more than 5 centimeter sized, any object is there, any boulder is there, that we are avoiding that. And also shadows, because it is very important that we have to have necessary power in the system. So we have to avoid long shadows. We are doing a propagation. In case it's 12 days the rover was working on the moon, and 1 hour rover is stationed at a place, we have to propagate for the next few hours, so that next path planning has to be planned. For that, we are propagating it and see whether any shadow will be coming more on the rover, so that it can be stationed in a proper place, so that the power problem is not there. So that is done, every day it is done, and ultimately rover could move about 102 meters with the different 12 segments, 13 segments time. It has moved about more than 100 meters, and all the 14 days it was perfectly working on and it has done a lot of payload operations there. And regarding communication and power, we made sure that enough power is there for rover, and enough solar power is getting generated in the battery as well. So that is made sure. And communication-wise, rover communicate with the lander only, and lander only can communicate with the ground deep space networks as well as with the CH2 orbiter. Now you see the RF communication strategy-wise, we can see that important role played by the CH2 orbiter also. We used the CH2 orbiter for many purposes, including this communication, and also for landing site imaging by CH2 OHRC. Okay, here this CH3 propulsion module can communicate with the deep space networks, DSN, JPL is there, ESA is there, India, ISRO's IDSN is there, and also CH3 lander can communicate directly to deep space networks, and it can communicate with the CH2 orbiter as well. Similarly, CH2 orbiter, anyway CH2 orbiter is communicating with the deep space network, our 32-meter antenna as well as 18-meter antenna daily. And both the bands, frequency bands considering S-band and X-band are used. And for lander, rover can communicate only with the lander, and it is an X-band communication. Now I will request Dr. Gauri Shankar to proceed with the further science objectives and products. Thank you.
Good morning, all. It's my pleasure to present some of the initial science results, what we got in Chandrayaan 3, which is complementing the initial results, the mapping, global mapping results, what we got from the earlier orbiter Chandrayaan 2 and 3. So the previous speakers talked about the technological aspects of this achievement. I will be presenting on the scientific aspects of it. So it's not only a technology demonstration mission to go into the moon, land there and rove there, but it had also a suite of instruments. These instruments are carefully chosen to complement the observation what we got earlier by our missions and also some of the missions of our partner agencies. These instruments which are there in the lander and also in the rover or the same as it was in Chandrayaan 2. You know, the Chandrayaan, we had the success of orbiter, but we narrowly missed in soft landing on the lunar surface, just a matter of few kilometers. These instruments, what I am going to present, and also the initial results, what I am going to say, in line with the scientific objectives what we have put forth for this mission, both Chandrayaan 2 and Chandrayaan 3. Basically, we need to study what is the near plasma environment, what is the electron density, the ions concentration, how that will affect the radio communication when we go and establish our settlement. And it is also going to study the surface parameters, the physical, the chemical, elemental, mineralogical aspects. So to consider these two objectives, we had 5 instruments, 3 are on the lander and 2 are on the rover. I will get into the details, but in short I can say the lander had a Langmuir probe to study the ionosphere and also a seismometer to study the ground vibration and a thermal probe, basically a thermoelectric properties analyzer. The rover had 2 instruments, both are for finding the mineralogical and elemental composition of the lunar surface with in situ analysis, whatever we have done earlier or global mapping from 100-kilometer orbit, but the in situ analysis, that too in near to the South Pole region, that is the element. So it had 2 spectrometers which are operating with 2 concepts like laser beam induced and also the alpha particle X-ray spectrophotometer. One is good for elements of lower atomic number, another is for higher atomic number. Another interesting instrument also we had, which is not having such relevance for lunar surface, but the propulsion module which has helped us in taking the lander module from launch phase, the injection phase, to the landing phase, to the lunar orbiting phase, has had one interesting instrument, which is a simple instrument, which is of futuristic in nature. It had a spectrophotometer, which can take the reflectance in near infrared region with just simply 6 pixels, how a habitable planet behaves when the sun is hitting it. Like sunlit portion in the near infrared region, it's measured by this particular instrument. Basically, this is for a future purpose, like when we go for finding some exoplanets in other solar system, we will be in a position to compare with these results and try to take some decision. Another interesting instrument which I have not listed here is a small passive instrument from NASA, basically a laser retroreflector array. It is going to be a permanent marker on the lunar surface, that too in lunar South Pole, for current and also the future lunar missions. It can help in locating themselves. The future missions can help in locating themselves by sending just a laser pulse and getting it reflected, because it doesn't emit anything, it just reflects whatever it falls on this. So, with this brief background, I am going to say few initial results what we got from the lunar science point of view. Basically, the 5 instruments, Langmuir probe, electric sensor, the seismometer, the spectrophotometer, which are operating with two principles in rover. The first one is the Chandra's surface thermophysical experiment. Basically, it was meant for studying the thermal profile of the lunar surface from top to around 10 centimeter below the surface. It had 10 thermal sensors, which are not equally distributed. Few are, closely placed in the top and, with the distance at the bottom. It also had a control penetration mechanism so that you can analyze the compactness also, how the surface is compacted, what could be the physical structure of the lunar surface. And it also had a heating source so that the thermal conductivity, the heating source will go to the bottom at 10 centimeter. From there, it sends the heat, how this is getting transmitted to other region to the surface. So the thermal conductivity of the lunar surface also was analyzed using this. The initial interesting results, what we have found, is shown in the first graph. You can see a thermal gradient of around 60 degrees Celsius from the top of the soil to the 10 centimeter below the soil. And another interesting feature is seen in the other graph, which is in the right side, where the gradient, which is of 60 degrees on the top of the surface, on the first day of the lunar day, is slowly coming down. It is narrowing down on the end of the lunar surface, basically indicating the poor thermal conductivity what the top 10 centimeter regolith has. I can tell you this is the first detector or direct measurement what we have seen, the humanity has seen on the lunar surface, that too in the near lunar south pole. The results from this instrument certainly can give valid vital input for us to choose the material when we are going to establish some infrastructure in the lunar surface for different purposes which the entire global lunar community is speaking about. The second instrument I am going to talk, which is on the rover. Basically, it's a spectrometer. It's operating in a principle of sending a laser pulse, ablating the surface and measuring the emission which is coming from, which are characteristic to the element which are present on the lunar surface. Maybe in a simple terms, you can say emitted plume as a result of surface ablation by pulsar laser is measured by this instrument. You can see the peaks which are characteristic to different elements, and to our surprise, which was not found on the orbital analysis, presence of sulfur, that too in abundance, is identified this particular instrument, apart from identifying some of the other peaks like iron, aluminum, titanium, chromium, and calcium. Another instrument of similar nature, which is APXS, I'm sorry, can somebody help in moving to the next slide? Yeah, this also is a spectrometer which works in a different principle. It has its own radioactive source. It emits alpha and X-ray particles on the surface, and the elements which are present react to this particular X-ray, and the characteristic X-ray lines corresponding to the element present is measured by this particular spectrometer. Again, this particular instrument has helped us in discovering the presence of minor elements including sulfur, as was done by the previous LIPS instrument, and also some of the expected major elements like aluminum, silicon, calcium, and iron. And I can tell you that the finding from these two instruments certainly can have significance to infer on the mineralogical composition of the lunar surface, and also, that too in the near South Pole, where more activity is going to happen from humanity in the future. One instrument, a Langmuir probe, which is on the lander, basically to study the plasma, near plasma ionosphere, basically to study the electron density and ion density, is mounted on the lander. It is so characteristically placed, which is the lander is about 1.5 meter above the surface, and the probe has gone 1 meter from the lander surface so that there is no interference from the lander body. And one interesting picture, which is in the bottom of the slide, taken by the lander camera, which shows the shadow of this probe on the lunar surface. It has a 5 centimeter metallic spherical probe, and it measures the return current by applying a sweeping bias potential, which ranges from -12 to +12 volts. The sensitivity of this instrument is it can measure the return current as low as a picoampere, that to every millisecond. The initial results reported low plasma densities in the lunar surface, maybe tens of hundreds of electron per cubic centimeter, or we can say 5 to 30 million electrons per cubic meter, which is relatively sparse compared to the Earth atmosphere. And this particular study or the results can help us in finalizing the frequency what we need to use for when we go for doing some radio communication on the lunar surface. Suppose if you have a settlement, how you can communicate, which frequency you can use, higher frequency or a lower frequency. So certainly this particular result will help in that phenomena. Yeah, another instrument which is on the surface of the lunar South Pole, but it's mounted on the lander. It is dropped basically to see the vibrations on the ground. These vibrations could be either natural or artificial, like it could be moonquakes or asteroid impact or any artificial event, including the rover movement or drilling activity. All those things can be measured, and it's a MEMS-based instrument with a cluster of 6 high-sensitive accelerometer, and the external vibration leads to a deflection in the spring, and the spring direction changes, resulting in a change of capacitance, and which is converted into a voltage, and that is measured by this instrument. Through the graphs we captured in the left side, there are 2 graphs, blue graph and the red. The blue graph indicates the artificial vibration which has been created by the rover when it was in operation, when it was moving from lander to explore the surface. And the bottom one is indicating a 4-second event which is not conclusively concluded, means it indicates that seemingly it could be a natural phenomena, could be a meteoroid impact or a moonquake, or all those analyses are going on. So during this one lunar day of operation, we had recorded 57 events of rover movement, which is shown in the pie chart, and more than 100 events of instrument operation, both the chaste and the seismic activity, the other one, the instruments which are on the rover, and more than 50 unidentified events. This particular segment will be of interest to the scientific community. The results from this Chandrayaan 3, the in situ analysis, will not be analyzed in isolation. It will certainly, once we will be doing individual analysis also, bringing out some scientific results, but also it will be analyzed in correlation or in relation with the results what we got in Chandrayaan-2 orbiter. So I'm trying to show here the connections between the results what we got in Chandrayaan-2 and the results what we are going to get in Chandrayaan-3. Basically, you can see the localized in situ measurements what we got, what we are going to get in Chandrayaan-3 is going to complement the Chandrayaan-2 goals. For example, I can tell the radio occultation experiment what we did in Chandrayaan-2 can complement the measurement of the near surface plasma or which is analyzed by our Langmuir probe in Chandrayaan-3. The thermophysical properties analyzed by chaste in Chandrayaan-3 can help in constraining the model which we are using it for analyzing the surface hydration and surface roughness in Chandrayaan-2 using the two instruments. Just give an example. So this is not science, but again, one or two slides I would like to say, which are all the other things which we have done, which exceeded the mission objective. Just before end of the lunar day, an unplanned activity was carried out, which has high significance for the future missions. By retracting the primary ramp, which deployed the rover, and also the three instruments, Chaste, Ramba, and ILSA, the two engines what we used for landing were fired for just 1 second. This has helped the lander to go up around some 40 centimeter above and then land some 30 to 40 centimeter from the initial phase. This is of significance in two angles. One is we could do the measurements what the lander instruments did in the first place, it could be repeated on the second place. We did. It is another level of, checking whether the consistency of these measurements, number one. And number two, how we can reignite the engines so that if there is any future sample return mission or there we can try to use it. So that significance, it has helped. And this is the fantastic image. What we got is a classic image. What we got from the OHRC, we call it as Orbiter High Resolution Camera mounted on Chandrayaan-2. It is the highest resolution imager as on today on the lunar orbit, and it has taken the lander, which you can see in the center of this image, a white pearl-like thing with its shadow. So you are seeing the shadow of the lander among the shadow which are created by the craters. It's worth mentioning here that this particular instrument, which is of in Chandrayaan-2, the orbit high resolution instrument or the data, is given to other partner agencies to help them in finalizing some of the landing sites for their future missions. This is my last slide. Sorry for taking extra time. I would like to say that this mission is not Indian national endeavor alone. It had a lot of ingredients to say it's an international cooperative mission. We mentioned there is a LRA from NASA. Apart from that, interestingly, they said there are some network of ground stations what we used, the countries we have represented here, and we also had support from 100+ companies, both from India and abroad, for through purchase procedure or sourcing the components for this. Certainly, The data from this mission will help in bringing more collaboration nationally and internationally. And we close this presentation by the picture of lander majestically standing on the lunar surface, taken by the navigation camera, which is mounted on the rover from a distance of 30 meters. So thank you so much for your patience.
Thank you. Now, considering the time limitation, we'll take maybe one or two questions. First one is on the navigation algorithms. So what I have to tell here is we have used more than 6-7 measurements, including velocity measurements, altimeter, as well as acceleration, and also camera for the navigation and guidance. So the second question is regarding the why the Vikram and the Pragyan did not wake up. I request Anurup to.
Yeah, this is a question that we have been facing throughout. See, the mission was designed to last a lunar day, and then we allow it to sleep, and then people got so attached to the mission that we are all facing questions like, hey, why didn't it wake up? Why did it wake up? So the emotional attachment, yes, we are encouraged by the emotional attachment that is being shown to the mission, but the mission has completed its objectives. So whatever we get beyond is a bonus, and will add to science in whatever way it is possible. But the reasons could be anything, because considering the very cold temperatures of around 200 degrees Celsius, plunging down at a fast rate during the lunar night, the mission is not designed to do that. So, but still, that is anyway, it has finished its objectives.
Thank you. What is the fuel remaining in the booster module, and what we are going to, how it will be safely disposed?
In fact, for any mission, any spacecraft mission, including Earth orbit or interplanetary or lunar orbit, enough fuel will be loaded so that to take care of any dispersion levels, known or unknown, injecting orbital parameters, dispersion, etc. So that way, our propulsion module also was having a lot of fuel stored in it, but luckily because of the trajectory, the perfect planning and the perfect thrusting, everything, the lot of fuel left now as of now. I don't want to tell the actual number here, but as such, this fuel, we are planning, our high-level committee will be going through it, and now the propulsion module is in 150 kilometer by 150 kilometer orbit with some fuel there. That anyway has to be decided later.
So thank you. And I think the advice to other countries will be design, test, simulate, go on testing, do the simulations, so that there may not be much of an issue during the flight. And one more question is again to Anil only, the launch shift of 4 seconds to avoid collision. You want to answer that?
What is question?
Launch shift of 4 seconds was mentioned to avoid collision.
Yes. Okay. See, this is a practice. It is a mandatory practice for not only for ISRO, all the space launch vehicles. That is, before launch, the liftoff should be cleared. So it has to be analyzed against the, now you know that debris, number of space objects in the orbit, especially Earth orbit, is so high, and even NASA, US Space Com is tracking more than 30,000, cataloging more than 30,000 objects with size more than 10 centimeter. See, this always gives problem. Close approach criticalities are there with the ascent phase of the launch vehicle as well as the initial orbital phase. So this collision avoidance analysis is a mandatory thing for Indian launch vehicle for clearing the liftoff. And for this LVM-3 launch that particular day, the nominal liftoff time when we analyzed, we found that during its first orbital phase of Chandrayaan-3, many objects, actually including operational objects, are coming close less than 1 kilometer to that orbital phase. So we have shifted it by 4 seconds to account for all dispersions, everything, and inaccuracies in the orbits, etc., orbital observations, etc. So we shifted by 4 seconds to avoid a close approach by other space objects.
So thank you IAC for giving us, thank you once again for giving us this opportunity to present Chandrayaan 3 as late breaking news. Thank you.
Thank you.
We will be ready in literally 2 minutes, so if it's a countdown, you would say 2 minutes and holding. Bear with us, and soon we will do the real countdown then to the launch of the event. So, let's count down. 5, 4, 3, 2, 1, 1.5. 0. Launch of this session, Popularizing Space. Meet the astronauts, meet the space people. And as you can see, we have a very good lineup of astronauts working themselves through these exciting days of the IAC 2023 in Baku, Azerbaijan. We have met a lot of people. We have really found some excitement, some good interest from the side of the people here. And we would like to discuss that because popularizing space means we try to bring the message that space is of benefit for us, that we all participate and benefit from the chance to go into space, which is not a century old, it's something like 70 years old. So we are living in an exciting time, and the astronauts, the cosmonauts, the taikonauts, people from all sorts of countries that go into space are the witnesses of this benefits and of this exciting chances that we have in space. But it also means populate space, which means that we have a number of ways now to get into space, which is new. It used to be some exclusive right of people of nations who have developed a space program, who have a launch site somewhere, who could launch rockets and also human beings into space. Now we see that there are many ways to space, and I'm very happy that we on the podium can illustrate that firsthand by our selection of participants today in the podium. I will not introduce them, I will leave it to them to introduce themselves and open this session with the question, how actually did you become aware of your chances to be a cosmonaut, an astronaut, a flyer into space? We say Raumfahrer in Deutschland, and it's even an astronaut, but he had to leave from Austria, Franz Fieberg. So many names, the same goal, to fly into space. I want to give it to Anna to open it. Short introduction of yourself, what is your professional background, and how did you become aware of the chance to fly into space?
Hello everybody, I'm a Russian cosmonaut. My name is Anna. I already 11 years in my professionality. I was selected in the Cosmonaut Corps in 2012. I was 27 at that moment. Why I didn't do that before? Because I didn't know about that possibility in our country. It was a first open selection for all citizens of our country. For me, it was a surprise when I realized that idea and that possibility, opportunity. I mean, I realized for me that I really fit to that professionality, and I wanted to be a cosmonaut, and I sent my documents in order to have a chance to participate in that selection. After my 10 years of preparation, of training, I was in space. I flew my first time, and I recently returned from space this March. I was in space about half a year, and I flew on American commercial program spacecraft, Dragon SpaceX Crew 5. I'm really glad with that. I really like and love my crew and the specialists who prepared and trained us. And now, after my rehabilitation, I again ready to go, and I'm waiting my next assignment and next crew.
Thank you, Anna. And I noticed that I'm feeling already such at home in Baku and in Azerbaijan, that I forgot to introduce myself. So my name is Reinhold Eberl, I'm sorry for that. I had the opportunity to, I studied physics, I was very interested in astronomy, and then changed the last syllable, and it became astronaut when there was a selection in Germany. I flew on a Russian vehicle, the Soyuz spacecraft, to the station Mir. The station Mir at that time had been 11 years in orbit, 97, but it served good purposes for experiments and all sorts of experience that brought us to the International Space Station. And consequently, after that, I was working in the European Columbus Control Center near Munich and helped others to get into space. I'm now a professor in Stuttgart. We have the most experienced, let's say, of us, among us, JD Baku. And JD, your first contact to space, what was it?
So you say most experienced, maybe you should say just oldest. So I flew in space in 1985, before many of you were born, and I had a different pathway for the opportunity to fly in space. I had invented a new telescope and spectrograph to study the sun, and I proposed it to NASA to fly on the space shuttle along with 10 other telescopes. And it was accepted for that flight, and then NASA said, among you 10 investigators, we need to have some of you actually go and operate the instruments because you are the experts. And that's when I said, I'll go. And so it was a surprise opportunity at about the age of 40 to fly in space, and it's certainly still a memorable occasion. After that, I went to work at NASA as the chief scientist for the International Space Station for 2 decades after that.
Thanks, JD. We only know him as JD, but it's John David for the records. And I would like to make you aware of the possibility to ask questions. So we have the Slido function, the Slido app up and running, and it's your chance to ask a question through the Slido. I will eventually look what questions are coming in and then distribute it to our esteemed podium here. The next in the line, as you can see, is Victor, and this is also something that is quite new in spaceflight. If we look back at the 60s, 70s, the development was concentrated on US, the Soviet Union, later Russia. Now China is one of the players with a prominent space program, even the space station. But there are other ways in space that opened up when rocket technology for some private companies developed into a safe mode to go in space. And one who participated in such a space flight is Victor. Victor, your first contact, how did you come to the idea of being able to go into space?
Yes, thanks, Reno. Well, I'm Victor. My name is Victor Espanha. I'm from Brazil. Brazil is well known for soccer. We have a lot of good players there. But space was too distant for me. The closest launch site, it's up until 2,000 kilometers by my home. And last year I saw a great opportunity in a great company. It's called Crypto Space Agency. I invested in this company because I wanted to grow with a new community, to understand new ways to understanding the space and, going to space one day. And I invested in the company, and I was selected. I'm a living example of popularizing space, actually. And I'm very happy to be here with you, because we have a lot of things to do, to develop and explore new technologies, to send regular people like me, because I know that space must be for everyone. And if we want, if we wanted to space it is for everyone, we want to give a way for everyone. Thanks.
Popularizing space, that is the
Yes.
motto of our podium. And I'm not sure whether you gave high five to Sarah or Sarah gave high five to you, the sequence of your flight, but you, Sarah, shared the same experience. You were far away from space and suddenly you jumped into the possibility to fly into space. What was the story there?
So yeah, it was, the opportunity came when, honestly, I found the application online, and it was something that I'd been working towards for a while. So I do work in the space field. My background is in mechanical engineering, biomedical, my PhD is in aerospace, and it all started because I thought that we needed to be reaching further in our cosmos, in our universe, having a better understanding of our origins and the future of humanity. And that's how it all started. It started from that. And then I got a little bit more involved in astrophysics, which led me to the space field, because I found out that in order for us to have a better understanding of that, we needed to be sending more people to space. We needed to be developing more technologies. And that's how it started. I grew up in Egypt, so it wasn't really anything that was close to us. We don't have a human spaceflight program. There was never something that I could apply to or something that I could strive for, that I would know that, oh, maybe if I do this and this, then I could end up going to space. So it was very different. It seemed, but I knew that somehow more opportunities are going to come, things are going to change, and they did. And I found this program called Citizen Astronaut Program by a company called Space for Humanity, and I'm their second citizen astronaut, so they select people based on their leadership experience, community development, like there are a lot of different things. And they selected me last year out of many people from all over the world, which is crazy, and I still think they made a mistake. but it's an interesting journey, and honestly, it does show that for someone that wouldn't have the opportunity otherwise in their countries, it does show that things are changing, and it's a really good thing with opportunities that are becoming a little bit more accessible. So for someone who, has wanted this so bad and has been working for it, and, but there wasn't like really something that you could reach to have had that opportunity. And of course, like I still would like to go farther, and I would still like to go again. So it's something that I'm still working towards. And it's just an honor, and we feel very, I think all of us feel very, very grateful to have had that opportunity. And to be honest, the first thing I said when I came back was that everyone needs to see this. At least everyone needs to have the choice to be able to say that if I would like to see Earth from space, if I would like to go work in space, to have that choice. And that's what I've been working on now as well.
Thank you. Yeah, last but not least, in the line at least for me, you first this way around. It's Tuva from Turkey, and I think Tuva, you did it the more traditional way, if I may count my experiences, traditional. So there was a fledgling space program in your country, and that brought with it the wish to fly an astronaut. Can you tell us how you became aware of this possibility?
Absolutely. So my name is Tuva. I was an electrical engineer working at a company called Rocket Industries in Turkey. We were essentially developing Turkey's first satellite launch vehicle. And it was a joyous experience for me being in that company and working in the space industry and working on a launch vehicle at a capacity that enabled me to interact with many different components that goes into carrying out this complex mission. There's a saying called it's rocket science, it's not rocket science. There's a good reason why that term has become so mainstream, because in rocket science you need to work with multiple disciplines: material science, chemical engineering, structural engineering, electrical engineering. It all came together to create this potentially controlled explosion to send some interesting stuff in space. So I was able to learn a lot, and that really got me interested in space in a deeper level. So I never had the idea that I would become a national astronaut, a government astronaut, because that program that pathway was not established. It was not in the talks for a very long time. But in 2019, the Turkish Space Agency was established. Roughly 1.5 years after that, they announced the National Space Program, which has 10 goals for the next 10 years, ranging from 2 moon missions, establishing a spaceport, establishing a space technology development zone, and one of the goals in that 10 was sending the first Turkish citizen to the International Space Station on the 100th anniversary of our republic, which is this year, 2023. So after hearing that, I got excited, but they did not open up any applications. They mentioned that they would open up, but it could have been a closed selection process within the Air Force and whatnot. But then in 2022, May, they opened up. There were some basic requirements that you needed to meet. If you met them, you could apply. It turns out roughly 36,000 people applied for that program, and they were supposed to select 2. And after a long period of selection, a bunch of environmental, psychological, health-related, and I would say anything that goes into passing all those criteria, all those tests. I was lucky enough to be selected as one of the first 2 astronauts of the Turkish Space Agency, and we are set to launch in January. We have 2 missions. The Axiom's 3rd mission to the ISS. We have Alper Gezeravcı, who's training as the prime crew member for that flight, and I am training as the backup mission specialist for it. We have been in NASA's Johnson Space Center for the last 6 months, getting our basic training, learning about the crucial subsystems of the International Space Station, how to operate during the routine ops, routine daily ops, and also in some of the emergency cases. As private astronauts, we are not expected to maintain the station. We are going there to carry out experiments, but we need to understand how to behave and how to react in the case of an emergency. So we have been getting those trainings in a very compressed duration. And the other mission that we're going to carry out besides the ISS mission is a dedicated science mission on Virgin Galactic's Spaceship 2, and that is set to launch in March. And hopefully, if everything goes as expected, I'm going to be flying on that flight and carrying out some human physiology and also hardware experiments, and quite excited about that. Thank you.
So we have selection, competition, selection. What was the moment, JD, you thought, I'm out? We all know about the medical requirements for astronauts. We know better now than we did 50 years ago. Was it a medical thing where you thought, I won't pass, or is it something in the psychological test that you remember where you thought, okay, I'm out with this?
Actually, I never thought about the possibility that I would not pass the medical tests. The medical requirements are not as hard as you might think. You have to be in good health. You do not have to be a marathon runner or something like that in order to be an astronaut. But it's about good heart, good lungs, all of your organs are functioning the way they're supposed to. That's the primary requirement. And at my time, the psychological testing for a short mission, an 8-day mission to space, was not very rigorous, because you should think of it, it was like a camping trip where you're going to go away for a week in an unusual environment and camp out. And so most of your time is spent working to get everything done during that short camping trip.
Anna, was there a moment where you thought, oh, what people around me are much better?
John told all right. Yes, of course, you must not to be a marathon athlete, but you may. to be him. And if you have any favorite actions, you may do it. But first you have to have good health, right? With any specialties. And we have an interesting thing. You may have something in your body, I mean, a specialties. For ground, for Earth, it's okay. But medical guys, medical specialists, are really attentive to look on your bodies and is considering if something in your body, a specialty on ground, good, in space it should be no good. That's why any specialties may be may have reason to don't be an astronaut in that case, unfortunately. That's why if you are good to be an astronaut, and your body should be good also to be an astronaut in nowadays. Now.
Not forgetting that we are not only screened to be healthy in space, but we are also subject of medical experiments. I was to a large extent, and so it's also interesting to, for the statistics, to send people of different genetic disposition or in life situations to space to enlarge the statistic that needs to be set. Almost all astronauts agree to do medical experiment on themselves, drawing blood, collecting samples. I think you mentioned a couple of experiments that will be in your flight, you're required as an operator. So if you give my personal answer, if I'm asked, what do I need to do to become an astronaut? Most people think you have to have a pilot's license, you have to be fluent in Russian, English, Mandarin, whatever. You have to have an astronomist degree of astrophysics and a medical exam. I say, have a plan B. When you apply, the chances that you actually become an astronaut, when you're going through such a competition, the chances to become an astronaut are next to zero. I mean. There are so many competitors, so many that also want to go the same way. And if you are disappointed in being refused, it's not you that failed. They are looking for another type of people. Oh, there were so many of the same characteristics that they had to decide. Well, they didn't choose you, but it's not a catastrophe in life. So, having said that, I think we all got selected. We won the competition. We were prepared to go into space. Now we enter training. Victor, what was your first training, and how long did you train in order to be aware of what is around you in the spacecraft?
Okay, our training was just simple because it was just a quick suborbital flight, and we stay in Texas for 2 weeks before, training just like emergency and stuffs, and trying to understand how we can proceed in different kinds of scenarios, and trying to absorb, especially the mental health, because was something I'm a little scared, especially for me, because I was just working with civil engineering before, and we stayed there for 2 weeks in Texas in simulator, taking tests, and was a really great experience. But I wanted to come again and try to do like you did, because I'm seeing your achievements, and that's a really great, and I see the beautiful things that is to be a good astronaut. And my first experience was just ignite me to dream again for something bigger in the future, but was a really great experience for me.
So thank you. Before I go into Tuva, who is in actual training, I would like to again remind you of Slido. Maybe you can have the Baku again. Put your questions in Slido. I see a couple of questions already coming up. We will take them in a minute after we have arrived in space, let's say, in our temporal sequence. Slido is a program that enables you to either ask questions or like questions that already are in the system so that they advance to the top of the question being asked. Tuva.
Yes, sir. So for the last 6 months, we have been based in Houston, Texas, getting our training in Johnson Space Center, which is the Human Spaceflight Center of NASA. And they have all the necessary facilities to be able to train their astronauts to operate on board International Space Station effectively, efficiently, and productively. So it has been a joy of my life to be in that place. I feel like a kid in a candy store, to be honest. And so we have started our NASA training. We have been training in Axiom facilities as well. They're also training us on the equipment that they're going to provide. And we traveled to JAXA, Tsukuba, Japan, to get our training for the Kibo module. So to be able to operate in every module of the International Space Station, you need to get certified. Not necessarily as a operator level certification, but a user level certification. So since the private spaceflight missions have started with Axiom 1 in 2021, 2022, I'm sorry, all these space agencies needed to develop new training flows for user levels, and we have been getting those. We have completed a week-long training in JAXA, and it was a great experience getting a high-level, high-fidelity mock-ups of Kibo module, JLM, and getting familiar with the exposed facility as well. Then we went to EAC, the European Astronaut Center in Cologne, Germany, and we got another week of very intensive, very compressed training to be able to safely operate in Columbus module, how to operate the payload racks, how to carry out our particular experiments that are going to use Columbus facilities, and also react in the case of an emergency that might be unique to the Columbus module. And upcoming weeks, upcoming months leading us to our January launch, we are going to be continuing our training at NASA. Some of the NASA facilities, we are going to go to Huntsville, Alabama to get our payload training, since we are going to the International Space Station to carry out some experiments, and we have 13 in total, and we're going to use some US lab facilities as well to get some training on them. We're going to go to Huntsville, and hopefully after getting some refreshments on how to use the WMS. WMS is the waste management system, aka the toilet. They're going to make sure that we know how to use that thing, and they're going to ship us to the International Space Station.
There's nothing like the real thing, I tell you.
It is way complicated than I imagined.
The question, you are strapped down in that rocket. Is space far away? What were your anticipations in the moment of the launch? Did you expect it to happen very quickly or in a drawn-out way, like flying in the transatlantic?
It was interesting because when you're on the rocket and you're launching to space, it's and also because we were very lucky to have big windows and we launched during the day, so you can see the changes in colors, which is really, really interesting. And you see the colors going from light blue to darker blue to purple and then black. And the thing is that's the only thing telling you you're in space. So it's only this visual cue, which is a little bit confusing, and then you realize, so that was actually so much closer than we thought it would be. So that was really eye-opening, and honestly, it does make you realize, you know, we talk a lot about the overview effect, and I think it is really, really powerful, and it was a lot more than I expected it to be, because as an engineer, of course, you're skeptical about a lot of things, and you hear a lot of astronauts talk about it, and I was sent there to analyze that, and it was a lot more than what I expected. And when you've passed, you don't really pass a line, you don't really feel like you've exited Earth. And I think that moment of realization that oh, we've already left it. And then you realize how close it is and how actually small it is. When you see like the borders against all of it, it really, it breaks your reality in a way that is really difficult to describe, but I think the best way that I could put it is just it does break your reality and puts things into perspective we all know that we are in space, but then when you actually see it and you really understand that we really are in space. So it was much, much closer than I thought it was gonna be. And that's really changed a lot of things for me as well, like in terms of the connectivity between humanity and our connection with the universe and all of it. So yeah, it was very, not what I expected, no.
Do they make you experience weightlessness, Victor, Sarah, for the flight?
Well, for me, I had been doing some independent training before that, because for a year and a half before my flight, I was training just in case opportunity does arise. And so I had been doing some astronaut training in terms of analog missions, aerobatic flights, hypoxia, spacesuit doning on and off, sims with the spaceship 2, I think, simulator it was. So I'd been doing a lot of different types of training, so I have experienced on aerobatic flights, like +8 Gs, which was really intense, and I almost passed out. That was really, really a cool experience. So it's interesting to really experience that on your body, and then when you do experience it on the rocket, it is because when we were launching, I think when we were launching it, we reached 2-point-something Gs. Coming down, it was 5-point-something, which is really interesting to experience in the body, and it's not like very comfortable, of course, but with the proper breathing techniques, which you train for, it helps a lot. Yeah.
We arrived in space. By the way, the magical number is 8 minutes 30. For some funny reason, the Soyuz shuttle take the same time to fly into space. I'm not sure about SpaceX Dragon. I think it's in the order of the same thing. That LECO means main engine cut off, contact abdelenia. So the spacecraft is on its own. All the propulsion is ceased. And we are in a status of weightlessness, arriving at the station. And then I take the first question here. Anna, what was the most difficult thing you had to deal with when you were 6 months on the space station?
First, I want to say it was so interesting for me to work on station. We were so busy, and for me, maybe little difficult was not enough sleeping time for me because of so busy. All half an year passed so quickly for me. In 1 month before returning to the Earth, I realized we already 1 month will be here more. It was so quickly, so fast, because of many tasks, one after another. And really, we were busy, and I wanted to sleep. First, before my flight, I waited when finally I will be on station in order to just count to do my job, not only training. And on the Earth, I thought, oh, I really little bit want to be on the Earth in order to little bit sleep more. And have a cup of tea, real cup of tea in my hand. That's it.
Yeah, very understandable wishes. What we do on space, by the way, those that like the question, do you have any health issues related to having been in space, or you won't get an answer, an individual answer, but we may touch it later because there's some progress in medical observation, medical research in space, and it might affect the way to Mars. The question I see here is to JD. What can we learn from shuttle, space station to go on further? Is it only to be going out and explore further, or is it also bringing benefit to us on Earth?
Well, there are thousands of benefits that have already been delivered from the International Space Station, and there will be more space stations in the future, and I expect the next space station will probably be a privately run space station by some company. And the whole idea of involving more than just governments in space is a tremendous step forward. You might think that NASA considers them competition, but that's absolutely incorrect. In fact, NASA actually encouraged them by doing two very important things. First, NASA said, I need a truck to carry supplies to the space station. I just want to be able to call up DHL or FedEx and have them deliver our equipment. So NASA announced that they were looking for companies to do this. NASA provided some seed money to the companies, but the companies had to put in a lot of their own money. They had to build their own rocket, their own spacecraft truck, and fly it and prove that it works. And two companies succeeded in doing this, and NASA now just orders them up to deliver their packages to the space station. So this was a way for government to actually encourage industry to take on the space job themselves.
Yeah, on the way to the moon, to Mars, we learn a lot.
Yes, and so beyond that, we are already, there are commercial companies working on sending landers to the moon on their own and delivering packages for various government agencies to the moon. And hopefully one day they will be able to just deliver citizens to the moon to spend some time in an outpost.
Yeah, thank you. There's a question actually to Anna and Victor. You get well known in your countries with reporting about your spaceflight. You meet people. You're the second Brazil astronaut. What is what is it like to be a role model for the children in your country, for the youth in your country, for those that ask you questions? A role model meaning, because you could go into space, Anna, I could do the same, and I want to follow you. And do you meet people in this respect in your countries, Victor? Does it start a space enthusiasm in your country?
Yes, for sure. When I landed to Brazil, was a lot of reporters waiting for me, and for a couple of weeks, they were noticed a lot of times in TV shows, TV programs, because I had a good approach with them, as I am a regular guy in Brazil. Because the last astronaut, Marcos Pontes, flew to space in 2006. It was a long time. And when they see me, like a regular guy, you know, like engineering, working with normal things, usually, I see that they started to dream again with this possibility. Now became a real thing for them. And that's great. When I'm I've gone to schools, for example. The kids are starting to freaking out, something like that. It's amazing for me. It's not only amazing, but it's a great honor also.
And pointingly, this question came from a participant here in the room from Chile. So a country that yet has to find its identity and identify a cosmonaut and astronaut amongst its ranks. Anna,
Yes, of course.
you're a role model for girls. I cannot say differently. And you encourage them to follow on your footsteps. What do they need to do in order to be more represented in space?
Yeah, well, of course, every cosmonaut and astronaut, any before, during, and after them flights, do that part of our work, popularization the manned flights in space, popularization of any space work on the ground also. And especially from the station, we do that again. We are connecting with young people, with children, with students. Directly, that's why I participated in such project like to be a figure of doll Barbie. In order to show young children and other young people that professional from the side of toys in a game activities, to have it in their life and game activities in order to understand and to imagine that professional already from the childhood. It's really important to do. We are among the people, we are same, we do our special work, and we want and have possibility to share our experience with people.
And a question to Sarah. Do you think, after you've seen all the technicalities that surround spaceflight, mighty rockets, lots of fuel being spent to propel a couple of people into space, do you think that traveling in space commercially will be similar to traveling in a plane from country to country? And I want to hear the word green space from you. The word green space. How do we avoid that rocketry is polluting the way in the same way as automobiles or airplanes do?
Well, with how the technology is progressing now, it is becoming a little bit better, and rockets are becoming reusable. So the rocket that we were on was reused 22 times. And, well, of course, SpaceX now, like all of the rockets are also reusable, most of them at least, most of the parts of the rocket. So that's making it a lot more accessible. So imagine if we had planes that we had to only use once and then throw away. So that's also like not cost efficient, and we wouldn't be able to send people where when you land a plane, you have just about an hour turnover, and then you send it back out again. And with rockets, their plan is to, especially with Blue Origin, I know SpaceX has been doing it for a long time now too, is that the turnover time, we need to reduce that so that we can be able to send more and more people and, more frequently as well. And I do think that with the competition in the commercial area, with more people getting involved, with the technology, how it's progressing, with more people making it seem that it's more possible, with more representation also from different countries, you create more competition, more interest, more like how Turkey now is getting a lot more involved as well. I think that's really important because we need to involve a lot of different places around the world, and we need to really also promote international collaboration for that to happen. And personally, I would like to see, us be able to get on a rocket. You can buy your own tickets, get on it, go wherever you want. And also, when we're talking about just traveling around Earth, that is, in my opinion, it is in the plans, I think, for a lot of people, and it is being developed. It's very difficult, of course, because you need to have launch sites everywhere. So it creates a lot of, it's possible. But also when we're looking at not only traveling around Earth, but also traveling to space, to have a base on the moon, to be able to go to Mars, we need more nuclear propulsion as well, which is a lot cleaner. People are usually very scared about nuclear propulsion. But if you look at how much using the fuel that we are using now, how many people it has, affected and, health-wise and all of that, and killed throughout the years, it is a lot more than whatever we've done with nuclear. But of course, with nuclear, the accidents are much bigger. So you have to really study that, and really have to put a lot of effort into that to make it cleaner and to also shorten the periods for us to get to Mars. So let's say now with the technology that we have now, it'll take us about 6 months to get to Mars, but with nuclear, it'll take like about 3 days. So you reduce this time, so you reduce a lot of it because you reduce the resources needed for the trajectory. You reduce also the likelihood of humans developing, because it's also really, really difficult to maintain the physical health on long duration spaceflight because of bone loss, bone size density loss, muscle atrophy, and a lot of it. And also, if you reduce that, you reduce the duration also in radiation in that environment. So with nuclear, I'm a huge supporter, and I'm studying that for my PhD right now. So that's why it just comes up really quickly. But I do think that it is. I'm very optimistic, and I do think it is going to become a lot more accessible. We are working on it. We need everyone to be working on it. And it's, I think, also important to point out that it's not only for engineers, it's not only for scientists. We do need to have policymakers, politicians, marketing, business, all of that being involved, because progressing in areas like this is really difficult. So we do have engineers that are working on things. We have a lot of solutions that are already there, but they're kind of stuck in academia sometimes. They're kind of stuck in a country sometimes that can't really collaborate with another country. So I think we really need to be putting a lot of effort into that to see that happen. So a lot of really, because everything depends on funding and everything depends on policy. So we need to push for that, I think, to be able to use the solutions so that we are making space more accessible, we are being able to send more people, that everyone in this room can one day be able just to buy a ticket and be like, oh yeah, I'm gonna spend the weekend on the moon. Wouldn't you like that, I think? So that's the goal, and that's what I have dedicated my life to to doing, and that's what we're working on within my company, and that's what like a lot of my advocacy work as well.
To be fair, manned or human spaceflight launches are only a small amount of all the launches happening. And JD, you live next to Cape Canaveral. How many did you count in the last couple of months?
Well, since the beginning of this year, there are more than 50 launches.
So it gears up, and
I can stand outside my door and watch them all.
Green space not only comprises keeping the atmosphere free of exhaust, but it also comprises keeping space free of debris and thinking of ways to bring back stuff that you brought into space, like in the Outer Space Treaty already mentioned, and probably we need to renew it, back to Earth so that it does not harm any other commercial satellite or even the International Space Station. There's a question actually, and I'm happy to take that up here. Every person that goes to space can be considered an astronaut? Question mark. Citizens, astronaut, and private, as much as astronaut, as any space agency astronaut. Gives me an opportunity to introduce the Association of Space Explorers. JD is one almost of the founding members of this association. The Association of Space Explorers was founded in 1985. 1985 was the high time of Cold War, and people from the East and people from the West, astronauts from the East and cosmonauts, no, it's the other way around, came together in Paris in order to say, when we look down on Earth, we don't see these differences, we don't see these borders, we don't see East or West, we are around the Earth in 90 minutes, so it doesn't make a lot of sense to divide it in parts and spend time thinking about it. We don't see boundaries. And that brought together these pioneer people, among them Thomas Stafford, who has flown on the Apollo-Soyuz test project, as well as Alexei Leonov. And ever since this organization has grown, and now more than 3/4 of the world, astronauts, cosmonauts, psychonauts are in this organization. The organization says once you have been performing orbital flight, you are a member of this association. But in order to become an astronaut, there is a kind of commonly accepted threshold of height, which is 50 miles in the US, so 80 kilometers, or 100 kilometers, where physically the atmosphere is not longer a factor, which then is called the line or the boundary to space. And people, having crossed that boundary, come back and call themselves astronauts. And are received as astronauts, as people having seen Earth from above the atmosphere. I think this is the important point. And joining in describing what they have seen, that they didn't see boundaries, that they see our spaceship Earth in the blackness of space. And as long as we all share this message and bring it to the audience, we that had the privilege to fly into space, I think that is a good reason to call us astronauts. And that is the line that we are now following here. Anyone to say what was your favorite meal in space, or shall we go on to another question? Anna, your favorite meal in space? Bludi. Какие блюда ты любила?
Actually, we tried different types of food on the station. Mostly we ate, I mean Russian people on the station, Russian food. But in our canteen we had American food also, little Japanese and little European. And frankly speaking, I like and prefer my Russian food. I really love it. We have different types of food, desserts, porridges, side dishes, different types of meats and fish, and many kinds of drinks, juices, tea, coffee, etc. And on the station, yes, I already told you, I dreamed about real mug with tea. That's it, because we had everything. And recently, I found out for me that I already missing with food on the station. With my good pleasure, I'll try that and eat the food from station. It's really tasty. And even on the station, we had several times fresh fruits, which were sent us from the ground on a cargo spacecraft. Usually it is grapefruits, apples, oranges, and plus to eat onion and garlic also, real garlic, not powder, it's real garlic. It was so tasty and impressive there to feel smell when the hatch is opening, the smell of the fruits with garlic. And then eat it, it's really tasty.
Little things that count when you're in such an isolated atmosphere. Yeah, again and again I see here health issues coming up. Tuva, your stance on radiation. When you are in low Earth orbit, I think Earth is taken care with the magnetic belts, but if we go out, what do you consider will be the development of radiation shielding in deep space flight?
Does the question mention for the deep space or the Earth orbit?
Oh, to the moon is already deep enough. Yeah.
Sure, yeah. For those missions, when we leave the Earth's magnetic protection, we will be exposed to some really devastating levels of radiation, and that's why the initial exploration plans for Moon and Mars are envisioning us living underground. If we were to set up some camps and colonize, there are some on-the-ground concepts and ideas as well, but that would require a significant level of radiation protection. We can, maybe one idea might be to use the icy waters on the moon, melt them, and because water is a very interesting radiation protection shield as well. Sort of add in between the structure and try to reduce the level of ionizing radiation that an astronaut would be exposed to. So it is going to be an interesting journey. Besides the physical protection that we're going to implement on our vehicles, rovers, and whatnot, we might go ahead and try to alter our own biology. Over the next couple of decades, I am anticipating some advancements in biotech that might enable or some nanobots traveling in our bloodstream and sort of repairing our DNA using technologies like CRISPR. That's also another protective avenue that we might employ, thanks to the recent developments in biotech.
And Adele was very busy asking questions. For our last stand, we have 5 minutes, less time than it needs to go into space. Would you like to fly to Mars, Anna? A short one?
Why not? But first, we have to use the moon. It's closer to us. I think it's more possible. But who knows? We'll see. If it's safety, why not? It's really interesting to do something new, and it's cool.
JD, you are allowed to take Donna.
Yes, absolutely. I'm ready to go right now. No hesitation whatsoever. And of course, the radiation is a bigger deal if you're going to make that long trip. If you can hide behind water, as you mentioned, this is a good way. The best two insulators from the radiation are dirt and water. And if you can use, the dirt might not be so useful in the spacecraft, but the water is certainly useful. So you might have your spacecraft shell be nothing but water all the way around, a large water tank, and you live inside it.
And we both share an advantage that is the age, because the effects of radiation doses are only visible a couple of years later, and probably that is why the radiation limit for 50-year-olds is higher than, for example, 35-year-olds, even in the NASA books and in the commonly accepted radiation protection. Victor, to Mars, you had the hors d'oeuvre, let's say. The menu is still to come, yeah?
Yes. I'm not sure, because actually, if we go to Mars, we don't have ways to come back to the Earth.
Oh, that is not a good one.
And I will miss my family, my dogs. But I don't know, some days, who knows?
Sarah?
I would go in a heartbeat. If you tell me that I can, like, there's a mission tomorrow, I would, and that we wouldn't be coming back, because of course there's a risk of not coming back, I would do it. First, before before going to space, I always thought that was my dream. So that's always been something that I really want to do. And I thought, okay, spending some time in low Earth orbit, some time in the moon, and then eventually Mars. Mars, maybe. I used to say Mars, I don't know, it's going to be really difficult surviving there, and then there's a huge chance of not coming back. But since going, it's completely changed my decision, and even if we would go and I know that I wouldn't be coming back, I would still do it.
The privilege of the youth. Tuva.
Well, for me, it's a no. I would not go. Because when I'm usually asked, what are you most curious about space? I mean, when you go to space, what are you most anticipating about? And I always say Earth, which is a weird thing, right? You're off Earth. Well, how are you interested in Earth? And the idea of the overview effect has been touched upon many times in this panel. And what it does to people, seeing the Earth from that vantage point, the mesmerizing beauty of it, the thinness of the atmosphere. It's just an oasis sitting in the voidness. It's just blackness of the space. And it helps people to realize that this is a spaceship and we are all crewmates on it. And all the philosophies, all the ideas that we have come up with so far on this planet has been on the ground, I mean, from ground up. What kind of new philosophies, what kind of new perspectives we're going to develop when we were to just go out and see the Earth from that vantage point. So my final destination is going to be the moon, and just be on the surface, watch the Earth rise, have that perspectival shift, and hopefully come back and tell the story. So.
Thank you all for your honest answers. I'm sad that we have reached the end of the session. We overdid already quarter of an hour, so excuse us for the next event happening in here. Thank you all for coming. I hope you all want to go to space station now, or to Moon, or even on to Mars. It's your generation. I talked to the young ones that came in. It's your generation that can recreate the Apollo effect. I'm JD. We witnessed man walking on the moon, and it's only natural that we also would like you to see the advancement of humankind into space. It's interesting, it's challenging, it's dangerous, but it's worth the risk if we bring back benefits for humankind, new knowledge, and satisfy our curiosity. Stay curious, and we see each other at another occasion. Thank you for coming. I close this.
Good morning, everyone. Welcome to our session on Does Everyone Really Love Space Activities? How Communications and Storytelling Play a Crucial Role in Gaining Policy Changes, Funding Support, and Workforce Development. Thank you for joining. I know it is the last day of a very busy, long, exciting week, and again, just appreciate everybody joining us at this time. My name is Ian Christensen. I am Director of Private Sector Programs for an organization known as Secure World Foundation, nonprofit based in the United States. We focus on the sustainability of the space environment. Why space sustainability? Because space benefits society, and we want to make sure that that sustainability continues to reinforce and provide benefit here, and then that we can communicate the benefit of the space activities that we all do, and so hence the panel that we have today. So today, as we all know, is Public Day here at the IAC, where over in the exhibit hall, our colleagues in the space industry and agency community are directly interacting with members of the public, sharing and discussing the space activities that we're involved in and the benefits and role that those activities play in society. And of course, just before this panel, we had an excellent session with a great discussion with a group of astronauts sharing that direct personal experience with space and the benefit that it provides. But the sort of direct engagement we're seeing here at Public Day, that's not always possible. Most often, the general public and policymakers and others get their information about space activities from media sources, from journalism, from social media, from other sources of public communication, not directly from those of us involved in those activities. So the value and benefit of space activities that we all know to be true, the public may not see that as directly. And so we want to have a discussion about what our role is, how we highlight those benefits, and what we can do to more clearly communicate them. For example, space-based Earth observations. I think most of us here at this conference recognize that those things play a key role in addressing global challenges such as climate change, disaster response, and other such socioeconomic and environmental issues. But how do the public, the policymakers, and other stakeholders truly understand that value of those assets and those data, and how they apply to those problems on Earth? That question matters from a resource perspective, from a policies perspective, and from a workforce development perspective. So at the beginning of space activity, there have been questions, lost the clicker. There it is. There have been questions about whether this investment that we all make in space is worth it or delivers the results, given all of the other societal challenges that people see in a more tangible way. And yet, traditionally space activities, exploration, science, have been typically viewed positively in public opinion data, but that may be changing. So a review of social media data and media publications paints a more complicated picture. So these are some selected news headlines about the relationship of space activities to climate. So how does the so-called billionaire space race play into perceptions of our changing climate and the contributions that luxury activities make to that? How do those investments that the public might perceive in developing commercial human spaceflight capabilities, how do they relate to the value that the public perceives via spending that money in other ways? Looking then at social media and other more popular media, so there's in the U.S. one of the big events every year is the Super Bowl, and it's a media, it's an event where companies spend a lot of money on high-profile media campaigns. A couple of years ago, it featured Matthew McConaughey, and basically he was dressed as an astronaut, and he said, the new frontier, I'm going to stay here on Earth and focus on these problems here. Patagonia, very famous outdoors company, put out an ad that basically said, we're not doing Mars, we're spending our money for things here on Earth. So these sorts of kind of contradictory messages to where we know the value of space activities to be. So here in that panel today, we want to get into this discussion. How do we communicate better? How do we describe the value that space brings? What techniques, what messaging, what channels, and how do we engage with a much broader audience? So I definitely want to give my panel the majority of the time here, but I want to start with just a run down the makeup here. We have a great diverse group of social media experts, of journalists, and of people involved in space businesses, right? So they're able to look at this from different ways. So moving to my left, which I believe will be your right as you look at it from the audience, to my immediate left is Remco Timmermans, who is, read the right lines, content marketer and social media specialist for space at SpaceSide. To Remco's left is Camille Bergen, who is a senior business development manager at VAST and also is a very well-known social media influencer under the name @GalacticGal on, I guess I'm supposed to call it X now, right?
Everything.
Everything, all right. To Camille's left is Ksenia Ozkalk, who is the founder of Re.Brand Academy. To Ksenia's left is Sergei Stanokin, who is the head of the BBC Global News commercial representatives here in the Eurasia region. And to his left, we have Lei Wu, who is a producer and senior space correspondent at CGTN. So the way that we're going to go about this today is discussion-based. You've seen all the slides that we have to give. We're going to have a conversation, and then we're hopefully going to engage with audience Q&A as we get towards the conclusion of the session today. So Remco, I want to start with you. So as an online marketing and social media specialist focused on the international space sector, can you provide some opening thoughts to the issues that we outlaid here? Do you feel that the space industry is effective at communicating value regarding the use of space assets and data to address some of these global challenges?
Yeah, thanks, Ian, for the question. The short answer to that is no. The longer answer is a little bit more complicated, perhaps, because the space industry used to be very good at communicating what it was doing. In the 1960s, 1970s, during the Apollo era mainly, during the space race, a lot of money was put into marketing, into communicating what was going on and who was going to win the space race. After the space race was over, that money was no longer there, but the space industry continued to evolve, yet the perception of the space industry stopped evolving. So when you talk to many people out there in the general public, I'd say, even though I hate that term general public because there is no general public, but to people out there, many people still have the idea that space is NASA, space is the Apollo program, and didn't that finish? So Even though I always say there's never been a more exciting time in space than now, nobody knows about it anymore.
Yeah, so in the Apollo era, that Cold War space race, we had a very focused activity set, right? It was very clear.
Yeah, it was
Now
very
it's-
clear. It was a race. And when we talk about storytelling, if you look at how the story of Apollo was told, it followed the basic theory of good storytelling. There were heroes, there were mentors, there was this challenge, there was a race, and there was a winner. Nobody got to marry the princess, but it ended in a slightly different way, but it followed the principles of storytelling really well. We lost that ability somehow to do that. The stories of space, I hate to say it, are boring and are not engaging.
All right, well, let's return to that point as we go. We just talked about space as inspirational, but is it inspirational and boring? That's an interesting point. So, Camille, you represent a couple of different stakeholders in this groups in this conversation. You're part of this new space company sector, this much more complex, not centralized environment that Remco was hinting at, but you're also deeply involved in social media around the space sector and around space activities. What are your thoughts on how space activities are being portrayed broadly? We had the commercial astronauts on the last panel. What about space tourism specifically, which can sometimes be viewed in a little bit frivolous manner?
Yeah, so I think kind of building off what Remco said here, space is like either boring and not talked about, or it's talked about from a, oh my gosh, it's only the billionaires going to space, and they're just leaving all of us behind because, like, I'm not a billionaire. I don't think any of us up here are. So we're all going to be left behind, and it's just their playground. And I think, I don't know if you had it up there, but in one of the other panels we've done at an event like this, we've talked about how there's a lot of headlines where it's like it's a billionaire's playground. And then also there's the aspect of it's harmful to the environment. It's harmful to us here on Earth, which, you know, further exacerbates the billionaires leaving us behind problem. But people see it as like a significant contributor to climate change issues. They see it as a billionaire's playground, as I've mentioned 5 times, because people mention it a lot. But what they're not seeing is all the good that space has for Earth and for humanity. You know, I know that part of the little write-up for this panel was about how Earth observation is particularly valuable from the space industry, and people just have no idea that most of the climate change variables that we can study, we can only study from space. All they see is that we're, you know, sending rockets and we're using all the natural resources, and it's like such a huge contributor to climate change. And then the other thing is that, like, in those conversations, we don't have like a lot of data to back them up either. So not only are we like exacerbating the bad, we don't really know how bad it is, because a lot of companies don't really like get into what are your emissions and how much emissions are you releasing from your rocket. So anyways, I think that it's a ridiculous, you know, multifold of issues. But I really see it from like on social media with 500,000 followers, people are just like, I hate space, I hate space. You know, and it's not the followers, obviously. They're like, oh, we love space. It's everyone else. It's a like, oh, you're wasting time, you're wasting money. Why would we not just spend that money when we have so many problems here on Earth?
So a couple things come back there, right? I mean, I would love to get into a conversation of how we respond, or do we respond directly to somebody that says, I hate space? Right? Where's the willingness to engage? What is the messaging that works in that kind of response? I think you've also added another level to the kind of the difficulty of the storytelling narrative here, right? And that if we're not open and transparent about the data and about our impacts, that makes it even more difficult to tell a story.
Yeah, and you know, I think when I was like a little baby science communicator, and I would get those hate messages, I would be like so adamant to like, no, are you kidding me? Like, let's talk about all of this. And it just fuels the fire, right? Because they're not like, those types of people that are engaging like that on social media are not like, they don't want to hear the opposite of it. And so I think those aren't the people that we need to be spending our energy on. I think it is a, like directly, I think it's a like whole encompassing problem that we need to solve from a bunch of different angles.
Yeah. All right, so Ksenia, I think come to you. I think, so you're an entrepreneur with a decade of experience in marketing and communications and now kind of focused on the space sector. What would you kind of add to these thoughts that we've started with Camille and Remco here? How do you characterize the problems that the clients that you're working with face in this area?
Thank you, Ian. Hello, everyone. And of course, a couple of points have been mentioned before by my colleagues. I just want to add exactly that. Actually, marketing kind of went wrong all the past decades because space had been always promoted as a byproduct of competition, starting with Cold War, right? Huge race, Soviets versus Americans, who is going first, who is going where, and so on. Second point, then colonization of Mars. We need to colonize Mars, right? Again, competition. And third point, space tourism. Who have more money? Camille mentioned it a few times now with billionaires going to space. So who is ready to pay more for the upcoming trip? Which company do you want to choose? But the good thing that now the narrative is changing, it's shifting. And finally, I think we're at this time where we can finally portray space as the next chapter of human civilization. And I've seen on the slides from here as well that the topic of climate change, that space technology can help us to combat it. It's just very crucial. And I believe that, actually it's very interesting that humans are kind of funny and interesting creatures because we always need either a competition to start talking about something or an enemy. And now we have found a new enemy, which is climate change. Is it good or bad? I don't know, but for space communicators, probably there is something positive on that. And recently there was this campaign on Space News that was featuring Greta Thunberg. On the first page, super big there, that she is the next space activist in terms of sustainability. I understand that there have been some concerns within the space community about that, and I get that point, because there have been so many people working in the space community for so many years, promoting the space sustainability and issues on climate change and how space technology can help us with that. And then, just like that, Greta comes and steals all the attention. I get it. It makes sense. But I believe that we should, all communicators here and all the experts in the space field, we should focus on the main goal. And right now, our main goal is actually going big and making much bigger outreach than it is right now. I mean, everybody would agree with me that even the best expert on sustainability in the space sector wouldn't get that much attention to the topic of sustainability and climate change like Greta. So I think it was genius featuring her there, because we need to get more influencers into the space sector from different domains. And Ian, you asked me about my clients' problems, so I just add 2 more points to that. In general, when I look at my clients, I see 2 main groups of them. The first group is smart, intelligent people who are working in the companies, so founders of the companies, but who have this entrepreneurial vibe. They have this drive. They understand the importance of space communication. They understand the importance of personal branding. They understand the importance of visibility. And they know that we need to promote the issues that we have. And they're ready to bring their top managers of the companies, engineers, to make them media ready, to give the interviews, to share the stories effectively. And then there is another group of people, which are also brilliant minds, but they, despite their groundbreaking researches and technologies that they're developing in their garage, they prefer to keep it there. But come on, let's say if you possess a Picasso art piece, if you keep it in the garage with a million other tiny things, what you have instruments there, who would see this piece? Who would see the value of it? But if you put this art piece on the wall in your dining room, when you have so many visitors coming there, their glances just will go on this picture, and like this, the attention will raise. So if you believe that you have a groundbreaking technology, a research that you've done that took you so many years maybe, don't keep it in your garage. Talk about it. you can't expect that people and media will find you in the garage there. They will, if you tell them that this research and your work exist. Only this will work. Thank you.
Thank you. So, going back to where Remco started with this, right? The competition narrative that provided that nice storytelling rubric. Good there, but doesn't, we need to think about that differently and may not have set us on a path that helps us address the challenges we're talking about here. And then this idea of when to show what you're working on, how to communicate it, not to hide it. I think there's a very interesting discussion to be had there, in particular about finding the right stakeholder groups and the right communities to provide that demonstration to you. So I do want to come back to that here in a minute or two. So continuing on, moving on down through our STEAM panels here, maybe shift a little bit to a more traditional media context here, right? Because it's still a very significant portion of the way that we communicate what we do and the way that the world learns about what we do. Sergey, from your perspective as your role in the BBC regional activities here, can you tell us about the challenges you face and how you see the evolution of commercial space and space activities more broadly and how it's viewed in the regions that you work with?
I think we just mentioned about competition, and competition is the crucial fact. Competition for the attention of the audience, competition for the sympathy, and either we're talking about any type of the media. Time is changing, and what I noticed that if we're talking about space industry, they're advancing, they're using new technologies, but in terms of their communication, the pace of development is not so fast. And what I mean by that visualization, the topic of our session, and the visualization, when we're using video, it's one level. If we're using photo, is another level. If we're using text, it's different. So it's not enough just to provide information. What is required now is to engage audience, to feel them, to give them experience. And how you would give them experience if you are putting talking head, and even if this is great scientist or the great manager or investor, brave investor who is investing a lot, still it's not enough. And while other sectors of economy, they're trying to utilize everything and all available modes of communication, I think that space industry is a bit lacking this at the moment. It's one point. And another point is that space community is so nice, and it's so comfortable to be within space community. Nice, clever people. They're solving great problems, and there is always something to talk about. But what about general public? How to involve them in this conversation? And how would you involve them if you are not using, as you mentioned, general media? It's not just media, it's media which is outside of the space community. And it's not easy, because when we're talking about PR, still PR is existing. It's public relation, and it takes time. It's not just efforts, it's not just money, it's time. So you've got to invest time into these relations. And on the international level, we can see it's done. On the national level, especially I work in Central Asia, Azerbaijan, and in Eurasian region. I can see that on national level, space agencies, they very often, they're quite happy with the national programs, and the communications limited to their own language. But still, space, it's the global phenomenon. If we're talking about innovation, it's a global phenomenon. So you've got to be part of this global community, of this global conversation. How to be part of global conversation when you rely just on journalists? Journalists, they've got their own agenda. Many journalists, they work under the order of their editors. And editors, they've got their editorial plan for the year. So what is important is to utilize the direct communication. And it's not just about science. It's about major issues which are relevant to your target audience. And target audience is the entire world. So it's a great job to to solve, and I think it will be done, because without this conversation, global conversation, it's fairly difficult to develop global industry like space.
Thank you for that. So, as I was listening to your remarks, and you said that the space industry was maybe a little lacking in using multi-modes of communication. I saw several heads nod on this panel along with that. Very just brief follow-up. I mean, we have some of the best imagery that exists in any industry anywhere, right? Why aren't we effective at using that, in your viewpoint?
Again, it's fairly difficult, because now normally on global TV, 30 seconds, this is the format. When you're using these great images, how would you format it? So it should be short, but it should be inspiring, informative. And how would you provide knowledge within these imageries? So it's not just image, it's text and repetition. If we're talking about conversation is great and successful and effective when you repeat the same idea a few times. And if you use just format of interview, nobody will listen for twice your interview, even if you're a great speaker. But then we're talking about corporate branding, we're talking about other formats, and this is commercial formats. When you have 100% control over your communication, it's not done by journalists, right? So you can communicate directly, but you've got to spend not just time, but money for this. And very often, as we just discussed, space industry is not prepared to invest into communication. They invest into the technology, into the personal and the human resources and all the rest, education, but not in communication.
Yep. And if you're a company, you might invest in PR, but it's going to be focused probably on business development and revenue generation opportunity, not necessarily a broader messaging, right? So, so I want to come to Wu Lei now. Lei, from your perspective, can you expand on some of the topics that Sergey and actually other panelists have already mentioned? How do you see this issue of space communications playing out in China and other parts of the Asian media? Are these issues similar there? Is there differences? And how have you, in your own work, kind of addressed some of these challenges?
Thank you, Ian, for having me today. And for the communication problem here, I think it's quite similar for not only Asia, but also across the world. We can see an increasing interest and popularity of space technologies, especially today we have manned missions, we have lunar missions, we have a lot of satellite projects, and a growing number of people have shown their interest. But there is a gap between the scientists, the engineers, and the public. We need more creative content to let the public know what is happening behind the huge project. Because sometimes when there are several launches, dozens of launches every year now in China, whenever we see a beautiful launches of rockets and manned missions, people are cheering. Tens of thousands of people will go to the beautiful launch site and cheer for the successful launch. But besides that, I think the public will need more creative content to understand what is happening. What are the benefits of the huge projects? How can the ordinary people benefit from these satellite projects? Because sometimes we need more, as Ksenia told, we need more content creators, we need more journalists, we need more influencers to join this community to let the public know more about the interest and the benefits of the huge projects. And so actually, this is my first time at IAC, and during this week-long event, I can really feel the benefits of communication, especially face-to-face communications, and also creativity and collaboration between not only space organizations, space institutes, but also media. And actually, this time we had a very good collaboration with Azerbaijan National Television, ASTV. We co-produced a special program. We have invited several high-level distinguished guests, and we talk about the challenges and opportunities facing for developing countries especially. And I think through this kind of creative and collaboration, not only for space agencies, but also media, we can have more creative content for the public so they can have a better understanding about what is happening in the space community.
Yeah, so thank you for that, Wu Lei. I think something you said that I'm thinking about there, trying to figure out how we move, take that broader. So we're here at this conference because we all clearly recognize the value of face-to-face communication and building that understanding, communicating what we're doing, demonstrating output of activities. But that's not scalable, right, to the global community that we're talking about on this panel. So I'm going to ask an unplanned question, but it just came to mind. Do you have any thoughts on how you scale that face-to-face experience or relate that face-to-face experience in a more mass accessible way?
Exactly. I think today when we face a lot of challenges, especially for the climate change, we need the space community play a bigger role in addressing these issues. But I think the community, space communities, and also media and every stakeholders inside this industry should work together, have a closer collaboration to address the issue together. Because it's a very huge problem and no one can solve this individually. That's why all the people need to get together once a year at IAC, and through this week-long event, every people can sit together and to chat with each other, to talk about the problems, opportunities of collaboration, and how to do we work together to address the problems together. So I think it's still the content, the creativity, and collaboration. We need to work together to have more collaborations to solve the problems.
All right, thank you. Yeah. And so we have reached exactly the midpoint of our panel, and I want to start bringing in audience questions. There's a number already here. Thank you to those that have submitted. Please continue to send those in. So several of our panelists have already mentioned that maybe we're not succeeding, or maybe we aren't succeeding in communicating our activities, our benefits, our results as well as we should be. So the first question here is about how do we fix that? And I want to start getting into some specifics about how we improve, better communicate around space activities. So Remco, let's start with stakeholders, right? Does it really matter if everybody supports space, or are there specific stakeholder groups that we should be engaging with, and why should we focus on, what is the value of a broader stakeholder engagement?
Sure, and I think we've mentioned a few of those things, and Camille said it, that it's not our job to convince everybody. There will be haters, and that's a fact. That's the same in every industry. Some people like it, some people don't. However, I don't think people realize what the true value, the true benefits of the space industry at this moment is to society as a whole. And I think that's the message that we do need to convey out there. You talk about stakeholders. Well, there's many stakeholders. The key stakeholder right now is the industry itself. The industry itself, both from a government point of view and from a commercial point of view. And if you talk about the gaps, well, many of the gaps were highlighted here. We heard the lack of budget. I wrote it down because I think the lack of budget is a big one in the space industry. Reason being, at least the way I see it, in new space, space is very tech-driven and very driven by people with an engineering and scientific background who do not necessarily see the value of communication, of marketing. In fact, I had a conversation yesterday, right here at IAC, with an entrepreneur who builds fantastic micropropulsion products. I'm not going to mention who it is or what it is, there's several of them here, but he said to me, literally, I don't need marketing because I'm selling to the industry. And they know about micropropulsion, and I only need to talk in my jargon to convince them of my product. And I was taken aback by that. Saying, okay, nobody knows that you exist except maybe a few satellite builders. There's a story to tell here. That story is amazing, yet it's not being told.
At one level, I applaud his transparency, but yeah, some work needs to be done there. And if that is a prevalent or even partially prevalent line of thinking in the industry, with our challenges maybe are even a little greater than we had anticipated here. So thank you that. So Camille, let's turn to you. I know in your work as a social media influencer, you've been doing some research around how space companies and agencies portray their activities. Can you walk us through an example of maybe what they do right, and some experiences you've seen that have been successful.
Right or wrong?
Correct, like what they have done right, yeah.
Okay, all
Maybe
right.
wrong
all
would be
right.
more
Fine,
fun,
fine. Yeah, wow. I thought you were going to ask me about the wrong. Okay, we'll get there. Okay, fine. I think that, okay, so one of my favorite examples of right is the NASA exploration, and not human exploration, the NASA astrophysics, looking out to the beginning of our solar system. And obviously a most recent example of this is the James Webb Space Telescope. I think that Twitter, X, whatever we want to call it now, account has at least 1 million, if not 2 at this point. That's incredible, incredible engagement on X. And I mean, of course, all the other platforms have a big following as well, but they're so good at telling the story of Webb. They were so good about telling why are we building this giant telescope? Why does it look the way it does? Why is it parked where it's parked in L2? You know, all of these things. They tell the why, not really the what. And I'm really, really big on that, is focus on the why, not the what, or more the why than the what, because the what will come. But if your storytelling does not focus and have like a really, really strong presence of the why, then the what is just going to take over, and that's where you lose people. And so I think that Webb does a really good job. Of course, the human exploration side of it, the why Orion, why Artemis, I think it's great, but I personally don't think it's as good as it could be. I don't think it's as good as the Webb telescope has been.
Yeah, I mean, I think Webb is something that, you know, when I talk to my parents who aren't space people, like, they talk to me about Webb, even though I know nothing about it, right? I don't engage in space science. That's not where I work, right? So I think that's a good example. So yeah, well, now let's do the more interesting side.
The bad.
The bad, right? and not just examples, but like, what can we learn from some of these examples in terms of correcting or adjusting in the future? Yeah.
So I think it goes back to that what over why. That's when it's bad, in my opinion. Big companies, small companies, big agencies, new entrants to the market, anybody. When we talked about this at the climate change conference in Norway in May, hosted by IAF as well, you know, I really started to dive deep into what websites are talking about from everyone perspective. And what I found was that most people, most companies, big, small, but most agencies, big, small, whoever it is, are so focused on, we build this hyperspectral imager. I'm sorry, like, I have an aerospace background and I don't even know what that means half the time. Like, what does it do? Like, why does it exist? I use the word what. It's a little not what I should be saying, but like, why do I care about that? You build this like really cool satellite. Okay, all right, cool. Why do I care about it? Because if you only talk about what it does and like the really cool, you know, it has 1,000 watts of power, like whatever it is, right? You're only going to reach the people that are already in your bubble. And here at IAC, I know today is public day, so the bubble is, you know, bursting a little bit. But for the most part, at these conferences, we're all in a bubble here. And just like you were saying with the micro propulsion system, like, cool, but like everyone and their mom has a propulsion company. So really, what does yours do? Why is yours cooler, more important, more efficient, whatever it may be? That's kind of what I'm seeing.
Okay, so Ksenia, let's kind of now go back out a little bit at a more higher level, right? We're talking about a social media environment here that is, let's say, volatile, be polite, right? Within that overall context, what is the overall landscape, current online atmosphere towards space, and are there any particular strategies that we in this community should be thinking about to respond to or react in that atmosphere?
Yeah, so again, I'm coming here with 2 groups of people that I observe on social media. The first one, and both are my favorite, by the way, both. The first one is the creators and storytellers, people like Camille we have here, we have Remco here. Astro Athens, Astro Alessandra, the one that you recently posted about, she's amazing with space news. Team Todd, who was supposed to be here but didn't come, right? The everyday astronaut. And they're amazing. They're the ones who push the boundaries. They're the ones who encourage the audience, the public audience, to be interested in space, to be more curious about space. And they work so hard. I mean, Remco, Kamil, how many hours have you been sleeping during this Congress? 3?
Not many.
Not many? Yeah, I believe so. Like, seriously, the creators, they have so much work, and they do it. And they do it with so much enthusiasm and energy. This is unbelievable. And then there is the second group of people, brilliant minds, again, intelligent, most talented space professionals. But before creating a post on social media, they believe that they need to do a set of tasks, which are reading 10 books, analyzing everything, whatever they can, and not can, writing a research paper, publishing a research paper, and then they're ready to write a LinkedIn post. And here's the thing, my favorite part again. I love this. My dear LinkedIn community, I am honored to share with you this exciting news that I've published this paper on this crucial topic for the space sector that is going to change our life. We'll make it before and after. Here's the link, read my paper. That's it. And what's happening, what's the result out of that, that the research, the amazing research that this person has conducted over the years maybe even, it stays within the community of scientists and technologists, engineers, and so on. Because nobody will understand this research, and nobody is warmed up enough for this research to read. Instead, if this person would have been sharing at least one post a month, if we are lucky, it's okay, at least once a month, about the challenges, about the experts that this person has met on this journey, about the ups and downs, about sad moments, about some realizations, not some secrets, but just like a little bit. It could have become a blockbuster that the whole world would be watching it, but we're not doing it. Sad. But there are some strategies you asked before, how can we scale it? And in my opinion, like the easiest 3 ways that we can do, and I like to be practical, so I see 3 ways. The first one is employer branding, basically encouraging the employees to become storytellers, to share the project experiences. And how can we do that? Well, we could facilitate workshops on social media and on effective communications. I mean, come on, you have enough people. And I'm sure that each and every one of us would be happy and willing to go to the companies and do these workshops. Right? Yeah, you're not against, right? Yeah, exactly. So we're ready. We just need a call, one call. But again, I know that as long as it's not written in your contract, nobody's going to do that. So maybe we could collaborate also with HR and see what can be done there as well. Maybe some incentives, some motivations, bonuses for the most motivated storytellers of the company and so on. And of course, guidelines. Because now what I see, that people who are even willing to share, these are my students that are coming to me, they're willing to share, but they're scared. They're afraid of what their colleagues will say. They're afraid of the judgment of their top managers actually as well. So if we would have these guidelines where it is written, okay, this is too much, don't share this, but this you can share. This would be so helpful. I mean, just one pager, come on. Okay, and we're willing to help with that again. The second approach is very important. Everyone, not all space stories need to be told by space community. Again, example, I want to get back to Greta Thunberg, very successful. We can get other influencers and storytellers from different domains. We don't need to rely on just storytellers from the space industry right now. I know it's the budget, of course, but it's also a promotion for that person. Space is cool, space is trendy. I mean, everyone wants to be in the space. So, and another example, for instance, I just checked today in the morning the video of Mr. Beast. Are there any fans of Mr. Beast? So recently, my sister is the fan, I see. So, but everybody knows him, right? So 2 weeks ago, oh sorry, 2 weeks ago, yeah, exactly, he posted a video, a car review, the cars ranging from $1 value until like $100 million value, and he was comparing them. In 2 days, this video got 15 million views. And in 2 weeks, I checked today morning, this is the freshest statistics, 132 million views. I mean, why not bringing Mr. Beast and talk about rockets? How cool would it be? How many views will we get? And it's not about the views, it's about the outreach. And the third approach is a hybrid one. My favorite phrase is, let's do both. So let's just do both. Let's think more interdisciplinary, attract influences from different industries and bring it to space. And let's encourage our teams, our colleagues to share more.
And I just want to add quickly, I love your all your points, but especially the first one. But I also think that, like, we don't need, if you're in the audience and you're, you know, if you're an engineer and you're like in that group that's terrified to post, it's okay. Like, we don't want to like add to your stress of your everyday job and everything. And, you know, working with some organizations right now, I don't need like the junior engineers to be the best science communicators. I need you to be really good at your engineering job. I don't need, you know, a mechanical engineer, for example, like to be a really, really, really good science communicator if that's not like your career. I need you to be good at your job. However, there's the bridge of, you know, different levels of storytelling and different levels of communication and different levels of Picassos in your garage that we need to get out, and different strategies we can take to help with that I don't think we have time for in 14 minutes, but I just wanted to add that.
Thank you. And I will say that I'm up here moderating a panel on communications in the space industry. If you looked for me on social media, you would find nothing but a LinkedIn profile that has no photo, right? So we all engage in this in different ways. Yeah. Yeah, and I was going to say, we just hired a full-time marketing expert at Secure World, and it is fantastic, right? Because it's somebody that is able to help someone like me who is not necessarily comfortable in that environment operate in that environment. So just kind of echo that point. So I want to come back down to Sergey and Lei here. So we've had a couple of questions from the audience about how do we make space a bigger part or a bigger presence in, you know, the global media environment, right? So space. We here, you know, recognize space as an important business sector, but if we look outside, it's a small sector, right? You know, because then you're talking about the automotive industry. I think the total market value of the automotive industry, you know, dwarfs what we're talking about in this industry, right? So, Sergey, coming to you first, what would you say to space companies and space stakeholders here in this room about how do we make it easier for you to translate our activities and engage in this broader media ecosystem?
It's easy, think big, so don't talk about details and try to build associations. I think this is what is lacking, because nowadays, again, specialists and space community, they're interested in facts, and they're prepared to deal with facts. A wider community, it's not the case that they don't understand, they don't follow this. And building associations, it's kind of building stereotypes or shaping stereotypes or changing them. And it sounds easy or difficult, I don't know, but I was thinking about two ways, or two approach and probably format. Approach that very often even about this Congress, what is happening, we start reading after Congress who said what. But before Congress, we've been just getting ready. But many people, they're interested in what will be tomorrow, not was yesterday. Yeah, there are historians, and you've got to take care of your heritage and so on. You can't learn without basics. there are many things, but still, it's not just younger generation, but would love to know what will be in the future. When you ask investor is coming to the company, and the first question is, what you are going to do? What are your plans? Yes, they're interested in financial records and they're checking books, but the main question, the team and the vector of development. And very often it's outside of communication. So we are talking about what has happened already. And another point is that there are only two basic formats in communications. I'm trying to be very simple. It's PR and advertising. PR, what others they want to know about you, and advertising, what you want to say. You've got to be prepared with this. You need to tell something, not to wait until somebody will ask you a question. Many journalists, they're saying that there are no good news. Bad news is good news. I don't agree personally. I think it's wrong. But still, we read in news very often just negative coverage of events. And with positivity, space industry should be ready. And but it's big work. It takes time, as I said. It's not just money. Yes, you need to invite specialists, and you need to call them. And yes, it is up to HR. And sometimes I decided to give you an example. We're talking about space tech, but I want to give an example of fintech, because in a way, it's nowadays it is similar. And one of my favorite fintech company, the most valuable, one of the most, I think it's the most valuable in Europe, is Revolut. And I use Revolut, and I love them. And one of the owners of Revolut graduated from the same university as me. And but for a number of years, I can see that they don't pay attention too much to communications. Yes, they prepare books, they talk about financial results, they invite journalists, or they deal with journalists, but they're not getting licensed in the UK and in some other countries. But I'm talking just about UK, because UK regulator, financial regulator, said that regulator does not understand the corporate culture. So they're very successful. They have got clients are happy, and they've got money, but there is a problem. And I think space tech is very similar. They're getting results. They're solving problems. They're doing a great job for the entire humanity. But there are a few buts after this.
All right, thank you. So come to Wilay. There's a question here from the audience that I'm going to try and weave into what we already had discussed. So you mentioned earlier the need for more creative content in the space industry. We've also seen and already discussed a little bit in this panel that distance, difference in global politics, difference in cultural context can kind of lead to a segmented industry where different parts are doing different things. So segmented, need more creative content. How can we better in the space community talk to each other about solving these issues, and is any of that creative content that you're looking for, would that help us in that challenge?
Okay, and actually, yesterday I was at the press conference of Astronaut Committee of the IAF. It was established, very cool, and all the astronauts from different countries sit together and share their stories of flying, orbiting in space and their experience in that microgravity environment. I was really excited to see this kind of experiences and the stories sharing to different people. And here's my point, and I think that we may speak different languages, we have different backgrounds, we live in different countries, but we share the same universe. We are living the same Earth. And all the problems, I think these astronauts, these top scientists, they can sit together, they can find the problems. And now, it's better to use the social media and platforms to reach more audiences. And I really agree with what our colleagues are saying, that not everyone can be a good storyteller. Not everyone has to be a good storyteller, but you do your part, we can do our part. We, from media, not only TV, but also social media platforms, we can work together, and we can help you to reach more audiences through collaboration and through creativity in channels, in content, in different forms of platform. So that I think we have different ideas, but for this space community, for the space industry, the challenges, we can always find a way to sit together, to share the problems, to share the solutions, and we brainstorming things, and we can collaborate from different ways. I think this is the 2 points I want to emphasize. Thank you.
Yeah, thank you very much, Wilai, for saying that, because that is a critical point. Building satellites and building spacecraft is a skill, is an art, if you like, but so is talking about it. So is the communication about this. Engineers, scientists built these great spacecraft. Professional communicators like us here tell the stories. We should collaborate. This is a big gap that exists in the industry, is that people try to do it themselves, which is great to a certain extent. So to your point, Ksenia, it is great if you can engage your staff, but it's even greater if you can bring in the professional communicators and help you. We are here to help. The media is your friend. We are part of the space industry. We are part of the story of space, and we love to help you tell the amazing stories. Take those Picassos from your garages and put them on the walls for you. So please reach out to us. The media is your friend. So.
And please keep building my spacecraft, because I'm not doing that anymore. And just like tiny little addition to Ksenia's point earlier is we like working with Greta. So when we, or others, right? So when we went to the climate change conference in Norway, Greta was right over there in Sweden, and she wasn't at the conference. And we really need to be bringing those people in, because we all need to work together, because we have a voice, but they have a voice, and sometimes they're bigger.
We need to unite.
Yes, we need to unite, and we need everyone to come together.
All right. So we have 5 minutes left, and there are way more questions than are here. So I will encourage the communication to continue briefly after the panel, if folks are able. Please approach. I'm going to try and do what I call a lightning round. I want a very quick answer to a few questions here, and I'm going to pick on people. This one I'm going to direct to Ksenia. All right. So there's a question here. So earlier this week we saw, and this is picking on companies, but we're going to do it. We saw Axiom announce a partnership with Prada, right? An association with a commercial spaceflight company and a luxury brand. Is there risk that these sorts of partnerships, which are meant to be kind of innovative and broaden into other stakeholders, is there a risk that they might actually heighten some of these perceptions that we're seeing about this is a billionaire's luxury good playground?
I just didn't hear very well. Did you mention the collaboration with Prada and Axiom
Yeah,
Space?
yeah.
Okay, that's correct. I think this is so tasty. Like this collaboration, I think this is just incredible. I mean, how else can we communicate better rather than connecting some haute couture brands with space? Space is trendy, space is cool. Prada is trendy, Prada is cool. I love Prada. Who loves Prada here, please? So I just believe this is amazing. And again, this is a perfect marketing example for me. How can we connect the brand that everybody knows, love it or hate it, doesn't matter, with the topic that needs to be promoted more? So I believe it's great.
Yeah, so use it as a point of talk, point of outreach, point of emphasis, point of discussion, and yeah, brought in. All right, thank you. So what's next here? So Wu, I'm going to give this one. Wulai, I'm going to give this one to you. We talked about face-to-face communication. We've also just emerged, in the last year from the global pandemic, in which face-to-face communication was very, reduced. The question here is. Can we learn anything from that COVID experience and the modalities that we use to improve the communications strategies we use in reaching a virtual audience in the space sector?
Communication strategies?
The question again? Yeah. So can we learn anything from how we communicated during COVID without being able face-to-face to apply to reaching a larger virtual community with space communications?
Yeah, actually, this time there are over 100 people from China showing at IAC after the pandemic. You just mentioned the pandemic. because over the past 4 years, international travel is very difficult for them to meet many friends and in person. And this time I can see it's very excited for all of them to meet their old friends and new friends, and especially also I meet Cassinia and also Ramco is in Norway this May, and we helped each other. I think from the space community and from our media perspective, it's very good to meet in person, to talk to face, and we can help each other. We can, help each other reach the people we want. Because on the other day, Cassinia is going to interview the president of the Turkish Space Agency. I didn't know that, and with her help, I talked with him later. I think also Ramco helped me a lot in Norway. I think we can have a lot of exchange and collaboration, help each other to reach the people we want, especially through this kind of face-to-face communication. I think this really means a lot for both of us, for all of us, to reach more audiences, because I got over 1 million fans, followers on social media. She got over 1 million, and together we reach more 2 million audiences. I think this kind of channels, we can work together to reach more people.
All right, very good. So unfortunately, we are under the minute, so I want to just go down the line, go down the panelists just in order here. The one thing that you would suggest to the audience that has listened in terms of a strategy, a technique, a messaging model that would help us address some of the complexities we're facing here?
Very brief, have a budget for marketing and communication and use these people here.
Something different than I've already said, I think be detectives, try to get down to that why. Why, be like an annoying little kid like I was when I was an annoying little kid. Why, and ask those questions in any of your circles.
Why, definitely. And also from my perspective, whatever you do, just go a little deeper. Don't be superficial with your findings, with your questions. Try to discover the hidden spots, because they're the most mysterious ones, and those spots are the ones that everybody wants to hear. Don't ask the same questions to the astronauts. What inspired them about going to space?
Always think, always say what you think, but try to think what you say.
And be creative and collaborative, always.
Well, thank you to the five of you. Thank you to you all.
Thank you.
And I hope we can chat a little bit at the stage. Yep.
I know that the panel is over, I'm sorry, but I really want to share with you later, for everyone who's interested, a 6-question winning strategy for storytelling. For any event, for any space topic, just come to me and get it for free. I will tell you, it will take only 2 minutes for you.